was branch of the StatMath unit for all practical purpose with several experts from applied stats also joining. So this is something one could also keep in mind that certain branch it comes out to have an independent development. Let us say my own area, algebra. I mean, it is not that that subject existed from remote antiquity. There was a certain time that the subject got its identity, roughly in the 7th century and in India. But then it develops independently. Having developed independently, it then rejoins with the main currents of math. So if algebra in isolation, that becomes a stagnation. It connects to other fields like number theory, geometry. So this is something which youngsters could keep in mind that having developed independently for 20 years, it's also good to get very intimately connected with the parent divisions and also other fields. And particularly statistics, you see, this is a statistical institute, but you see the vision of the founders that various subjects have been developing in ISI. And with the idea that statistics would be connecting with the other subjects. So I think that's all the philosophy I need to share. Thank you.
Thank you, sir, for those insightful words. I would like to now request Dean sir to say a few words.
Yeah, good morning. So this now this unit is ISRU. So it's basically from Biru to ISRU. So transformation or change, whatever we say. There is a specific objective, of course, to performing this particular unit when that Biru was formed, and now it is ISRU. So obviously that has also some specific objective. If you see that name, actually Interdisciplinary Statistical Research Unit, as far as teaching is concerned in ISI, it doesn't matter which department you belong to. So as a whole, we have statisticians, whether it is in ISRU or Applied Statistics Unit or STSU, is there. But of course, as far as research is concerned, since the name of this unit is ISRU, so naturally that research in interdisciplinary areas, that is of course that is what we want, and that is and that's very much important also in the context of ISI. And I would request that whatever that research in interdisciplinary areas is being conducted in this unit ISRU, that should be highlighted, so that the unique name of this unit will have that significance there. Of course, I know that the faculties are doing research in that in interdisciplinary areas, but if it can be highlighted in some way, that will be good, whether it's for the students and for us also. And so this journey of the particular unit from Biru to ISRU for 20 years, that's a great, I would say, and I hope this unit will flourish with respect to researchers, teachers, and of course these research scholars that will be there. Thank you.
Thank you, sir, for your technical remarks and best wishes. I now request Professor Debashish Sengupta to share a few words with us.
Good morning, everyone. This is a very happy occasion that we are celebrating 20 years of what is now called the Interdisciplinary Statistical Research Unit. as the Dean mentioned and the Director also mentioned, it started its journey as a breakaway from other units, but the name was different at that time, and after that the name had changed. Now, I will come back to the issue of the unit a little later. One thing that strikes me regarding this is that the naming of the divisions in the Indian Statistical Institute, I suppose there has been some coordination regarding the naming, and the matter has been discussed in the council, in the review committee, and usually the council. And the names that we bear today, the divisions that the names that the divisions bear today, follow that discussion. On the other hand, traditionally in ISI, the naming of the units have been more or less in isolation without regard to the names of the other units. It doesn't represent any division of work per se. It is, in a sense, the representation of what the faculty members within the unit actually do. So, as the composition changes, there are sometimes needs for course correction or renaming. My unit, the Applied Statistics unit, was previously called Computer Science unit, and at a later stage, after some discussion, the renaming was done. In this unit also, Bayesian interdisciplinary research unit became an interdisciplinary statistical research unit. So it is probably not that important that the names will have so much significance that they will represent as a group some division of work. It is enough that the names bear a fair representation of what goes on within the unit. So that is absolutely fine. But what matters is that, as the Dean said, work here need not be confined to one unit. There need to be collaboration, more so for faculty members belonging to a unit that bears the name interdisciplinary. So as long as the unit itself provides a conducive environment for collaborative research within and across units, intra-unit collaboration and inter-unit collaboration, that is absolutely fine, and that is actually very much welcome. I do not see some of the architects of this unit here. I think Amitadi was instrumental in creating the ambience for research that exists here today. Not just her, but because I do not see her, I'm mentioning her name.
She's abroad. She's abroad.
She's abroad, yes. Okay. So, in fact, some of us had some discussion in the tea club a couple of years ago that maybe we should have had Amitabh Day so that ASU looks a little better. It is no secret that research fellows prefer the ambience of the corridors and the rooms in this unit over what they find in ASU. So I can see some smiling faces from people who had been recently in that position. Now, coming back to this issue of interdisciplinary work, it's not just the name, but I think statistics inherently is an interdisciplinary subject, and it is. It does not exist in isolation, as Professor Manal has said. It needs interaction with various disciplines that which statistics serves and which serve statistics by way of producing problems worth looking. So that is a very important thing. But it is also, it needs to be recognized that it is not a very easy thing to do, because the most often what you will find is that there are people from other disciplines who need a routine application of statistics, and that can perhaps be provided by some students, research scholars, and that should be encouraged. But it should also be kept in mind that that sort of help is not enough. That does not help our discipline grow. For that, we need to get inputs, much more substantive inputs in terms of open questions. Questions that cannot be solved through regular methods that are available. And it is that which should spur our research. And it is this mode that can really lead to meaningful interdisciplinary work. I need not remind our esteemed colleagues here, I'm sure this kind of work actually takes place in this unit. But this will be a good occasion to remember that it takes investment of time and some unproductive time as well. That means the faculty members who get involved in interdisciplinary research may have to invest some time for which for a time there would be no return. That is very important. And at the same time, this needs to be understood not just by the participating faculty, but also those who evaluate. Because once I have been part of the review process for some time, and often I see the emphasis is very much on the outcome. Sometimes the outcome depends on what has been undertaken. And in some ways, for some types of research, the outcome can be delayed and the content has to be judged somewhat differently than in traditional theoretical work. So this recognition, I think, is very important. If this recognition is there at all levels, then I think meaningful interdisciplinary work is possible. In ISI, it has taken place in ISI for many years, and I hope the continuation of this unit with its current name and with the emphasis in interdisciplinary work will benefit ISI as a whole. Thank you all.
Thank you, sir. Those were
Just one suggestion which comes to my mind in the context of people coming together, that different units like the applied stats and this ISRU can come together to have some kind of a joint colloquium. So each unit is having seminars, and there are many seminars going all over the institute, and typically what happens, people don't have too much time to attend the seminars, and they typically get confined to a certain group only, which is fine. So alongside specialized seminars, if there is something like a colloquium at an appropriate interval, need not be weekly, it could be fortnightly or even monthly. So where all people are supposed to assemble, and the talks also should not be too specialized. The idea is that, okay, this is some work which possibly others could may take interest. So that's research which people potentially feel. So if there's a colloquium, there will be of course some kind of colloquium committee which could decide that this particular work can have a bearing in the other units. And those kinds of lectures would be held, and sometimes even people from outside the institute could be invited for a general institute colloquium. Primarily, the target would be ISRU, ASU, and StatMath. But in certain cases, people from, let us say, PAMU or geology and biology, if there is a particular work, there's a kind of a potential, then they could also be invited to attend, or even they could be invited to give talks if there is a chance of a strong statistical component. So a regular colloquium at a certain fixed interval is something which you could think of and as an institute activity. Thank you.
Thank you, sir. Those were some nice suggestions, and thank you, Devashish sir, for those inspiring words. We can now conclude this inaugural session, and we can move on to the academic session, which forms an important part of today's celebration. Today, we have three distinguished speakers whose contributions have enriched the field of statistics, data science, and interdisciplinary research. As a token of appreciation and gratitude for joining us on this special occasion, we would like to honor these invited speakers.
May I first invite Professor Devashish Kundu from IIT Kanpur to kindly come forward. I request Professor Arnab Kumar Laha to kindly present Professor Kundu.
Thank you, sir. May I now request Professor Shivashish Dashgupta, TGCRES, D, to kindly come forward. And I request Dr. Joyanta Jha to felicitate Dr. Dasgupta.
May I now invite Dr. Arnab Hachal from IIT Kanpur to kindly come forward. I request Dr. Minarva Mukhopadhyay to felicitate Professor Hachal.
Thank you, sir. Thank you, ma'am. We once again extend our heartfelt welcome to all our distinguished speakers and thank them for being a part of this celebration. With that, let's proceed to the first lecture.
5 minutes break. No, 5 minutes break. 5 minutes break.
Yeah, okay. So we will disperse for a 5 minutes break and then we can move on to the first lecture.
মাইক্রোফোন আর এখানে এমন কানেক্টিভিটি না, যে কেবল ওই কেবল আর আমাদের লাগেও না, কোথাও লাগে না, একমাত্র এইখানেই লাগে। দুটো কেবল দেওয়া আছে, একটু ম্যানেজ করে নেওয়া, এটা ঠিক হয়। ওটা যেমন কেবলটা
আপনি বেরিয়ে যান, আপনি ফ্লাইট গুলো দেখেন, ফ্লাইট ঠিক আছে, ফ্লাইট না না, এই স্যার স্ক্রিন স্যার আমাদেরকে অনেক কথা বলছে।
যেখানে ট্র্যাক গুলো আছে ওখানে ছিল, এই যে সেকেন্ড
এটাই প্রথম, তাই
এইটাই প্রথম, এইটা 1 ঘন্টার মতো চলবে, তারপরে ফেরত এসে আবার দুটো আছে, মাঝে হাইটি আছে, এইটার পরে হাইটি আছে, হাইটা থেকে এসে আবার দুটো
একটু দেখিয়ে দাও।
রিমোট করে দেবে।
এটা
হ্যাঁ হ্যাঁ ওটা কাজ করে এবার। না ফুল স্ক্রিন মোড, ফুল স্ক্রিন মোডে করলে রিমোটে সুবিধা হবে। দেখি
স্ক্রিন মধ্যে থাকলে এটা
আমরা বসে পড়বে দাঁড়িয়ে থাকি আমাদের বসলে চাপ আছে। না না আরে আমরা থাকবোই না।
তখন তো 12টা করে বেরিয়ে যাবে। এটা
We should announce the whatever is upstairs. Water is here also. Oh, here.
we have
আচ্ছা শুরু করো স্যার। Should we keep it here or somewhere?
May I request everyone to take their seats?
এখান থেকে আছে।
দিচ্ছি তো ঠিক আছে তো হ্যাঁ।
Announce.
We'll now begin with the first lecture of the academic session. Okay, quick announcement for anybody who needs water, it's available here. You can just ask for it, and coffee is upstairs. Starting with our first lecture, our speaker needs no introduction in the statistical community. Nevertheless, it gives me great pleasure to introduce him. It is an absolute privilege to have him among us today, all the way from IIT Kanpur, Professor Devashish Kundu, an ISI alumnus and academic descendant of the legendary Professor C.R. Rao. With more than 400 research papers, more than half a dozen books and book chapters, Professor Kundu has been awarded numerous awards and distinctions across the globe. He has been in several national level committees in the government of India, on several editorial boards of renowned journals in statistics and mathematics, and continues to work in statistical signal processing, distribution theory, and reliability and survival analysis, among many different topics in the subject. We are truly honored to have him with us as part of the 20th anniversary celebration. We now invite Professor Kundu to deliver his plenary lecture.
Hello, yeah. Good, thank you. Thank you for this. Yeah, thank you for the kind invitations. Thank you, Kiran Moy. And see, whenever I entered ISI, it always remembers me the first day. The first day when you entered the first district student, that time the director BP Odhikari was addressing us, and compared to that time, our batches was a kind of a larger batch. We have almost like around 25 students. So BP Odhikari was addressing, and he mentioned that I still remember that, and he mentioned that I know that all of you are good students. You have got into admissions into academia, this either engineering or medicines, but you have chosen to come to ISI. But let me tell you one thing, that if you have to go to US, this is the best place. If you have to stay back in India, this is the worst place. And see, well, that was the first. But the second thing what he has mentioned, he said that India still does not recognize statistics that much. It will take maybe another 25 to 30 years. to recognize that, and which comes out to be so true. Okay, and that's what it is, and we are really fortunate. But I think we have a real challenge also nowadays, and I mean, I think all of you agree with me, and I can also see this one that with all these AI and all these things, I think it's a big challenge what we are going to face, but at the same time, it gives lots of opportunity also. But anyway, without much ado, let me start my presentations. It is on the bivariate load sharing model, which is I'm currently working for the last couple of years. And well, this is basically the outline of my talk, as we can see. Very interesting. You'll see in the motivations one. This is a I have to thank one of my current postdoc now. I mean, part of our work also. Anyway, so the motivation actually came from one data set, which was a bivariate diabetic retinopathy data. And it was an experiment. And coming to the experiment was kind of interesting because this diabetic retinopathy is one of the eye conditions. Well, it is common among the diabetic patients, and it basically leads to blindness. And unfortunately, it is not possible to. I mean, unless you go for a regular visit, we do not. There is no symptom, so we do not find it. And so when it is being detected, there is not much you can do. It basically, you cannot reverse it back. You can only basically stop the progressions. That's what it is. So that's the reason this one that the experiment was done. And there was a treatment, which was the laser treatment, which was introduced. And so basically, so they are trying to test whether how good is the laser treatment was. Okay, so the way it has been done that they have chosen the each patients, and they have chosen one of the eye at random. One eye, the laser treatment has been given, and the other eye, there was no treatment. Okay, so they are trying to test whether it has any effect or not. And interestingly, I was giving this talk just 2 weeks back in Kathmandu. There was a conference on this, the Nepal Mathematical Association, and that one of these ex-AMS president, American Mathematical Society president, he was sitting there, and apparently he said this one that he was one of the person who was who was under this experiment. So that was kind of interesting. Anyway, and that was the first time I have seen. Anyway, so the data is like this. You have the data X and Y. X basically the time to blindness. As I said, that you cannot reverse it back. Only thing you can stop the progressions, but gradually the eye becomes blind. So that's what you observe. That the X, which is the laser treated eye, the time it takes time to blindness for the laser treated eye, and the Y is the other eye, which is the time to blindness. So that's what you observe, this bivariate data, X and Y. There are a couple of so this is basically the data set what we have. There are around 200 observations. There are only 30 observations which are complete. Okay, so in the sense that we have the data from both the eyes, the complete data, the complete time to blindness, both this laser treated eye and the other eye. There is a huge observations which are censored. You can see that almost like around 80 observations which are censored, and there are 54 and 96 observations are censored in either in X or in Y. Okay, and another interesting thing was that, which is I think striking one, that we have a couple of observations where X equal to Y, and couple of observations where your X plus, which means censored one, which is equal to Y, and X plus X is equal to Y plus. Okay, that means both of them are censored and they are equal. So, and that's significant number. That's significant number. It just cannot ignore. Okay. So the main idea was it. So there are lots of covariates also. This standard one, this age, sex, and the condition of the eyes at the time of the entering of the experiment, and which eye which has been given this laser treatment on this one. The last one is not that important, but the first three which are important. In these presentations, I'm not giving with the covariates one also. I'm just giving that without the covariates, but we'll see this one that I will get. Yeah, so there are two aims of this experiment. The first aim is that, of course, we have to see whether there is a significant difference between the laser treatment or not. That is definitely one of the one. And the second one, which that's the reason this load sharing things which are coming, that well, if an eye becomes inoperative, means which becomes blind, whether it has an effect on the other eye about the change of that eye. Yes, so that's what basically the two. Now we have basically two aims of this particular study. Okay, both of them are important. I mean, because so that's what this load sharing comes into picture. Okay, yes, I mean that's assumptions. What it's been usually it is being done that well. If one eye becomes inoperative, it is expected that the other eye is going to be affected because it's trying to take care about its load in some sense. So the lifetime of the other eye also gets affected. That is there. So that's the reason this one that that's what you usually call this the reliability of the survival literature, the load sharing model. That's what it is. The other component is trying to share the load. And of course, as I had mentioned, a significant proportion, which is x is equal to y, which cannot be ignored. And what is important here, we have lots of these load sharing model which are available in the literature, but none of these load sharing model can take care of that. Okay, that when you have this x is equal to y business, that's what it is. Well, I mean, it's a some schematic, simple picture. But as we can see, this one that's what it is expecting, that there are two components, two eyes, and when the one of the eye fails, then the load in the other eye. That's what it is. Similarly, here also, I mean, the laser treated eye and the other eye also exactly the same thing, and of course here both of them fail at the same time. So that's change. The load begins. I mean, yeah, the system basically stops. So yeah, so it's a simple the Kaplan-Meier curve of the two survival times which are being given. One is lying above it. On the top of this one is the laser treated one, and the other one is the normal one, the other one which is not being treated. So the natural question is that whether is it a significant difference? Okay, statistically. Well, couple of observations I think which are important, and so one thing what we observed that both the marginals are continuous. I mean, there is no problem about this one. That's absolutely okay, because that makes the life simple, and the kind of data what you have that is fine. But the most important thing is, as I mentioned, that there are several tiles. Okay, there are several tiles, and therefore all these usual bivariate distributions, which are the continuous marginal, which cannot be used. Okay, so that was basically the main issue of the main issue of this one, and you have this standard bivariate distribution, bivariate normal, bivariate log normal, Gaussian, Gaussian, that's all this bivariate distribution, but these are all absolutely continuous. Marginals are absolutely continuous. They are absolutely continuous. So therefore, probability x is equal to y equal to 0. Okay, so you cannot use
those distributions in this particular case. Okay, so what is the way what it can be done? So let's look at this the load sharing model. Usually the load sharing model, what we call this one that I have a system, okay, and it has a multiple components. In this particular case, there are two components. I mean, these are the usual assumptions in the load sharing system, and so I mean, we have a total load. It is being divided into different components, and therefore that whenever a components fail, and that particular load has been shifted to the other. Okay, that's what it is. It happens, and it is a very common. It's a very common in the particularly in the reliability setup. So the main difference with the usual one that because they're dependent failures. Okay, so clearly you cannot make them independent because if one fails, the other one, the lifetime of the other one changes. That's what it happens. Therefore, you cannot make them independent. So clearly, X and Y, they are dependent. That is one. The second one, which is also being assumed in many cases, as if the total load is the constant, and whenever one fails, so that load got shifted to the other one. Okay, so that's the way it is being done. Those kind of assumptions what are being made. Okay, and we have lots of applications. We can see this one, that one of the typical application, I think, where it has been started. I mean, you might be knowing this one, that when all these Boeing engine were installed, at the beginning there are only 2 engines, then they make it to 4, and all these things they have done it, and it is purely based on the load sharing things. Okay, because whenever one particular engine fails, the other one can take over and things like that. Okay, and there are lots of other applications about the generator and all these things. Yeah, so that's what it is. So let's look at the way we are treating this one, because one of the things that to keep it in mind that we wanted that the probability X is equal to Y has to be greater than 0. Okay. So what we are assuming that it's a 2-component system in this particular case. It's a simple one. The I is 1 and I1 and I2, and whenever we are saying this one that system fails, that means that the person becomes completely blind if both the components fail. Okay, that part is okay. And let's denote this one as component A and component B. Okay, so that's what you are mentioning this one. So what it says that suppose at the beginning, of course, that's what it is. That when the treatment starts, so when both the components are working, the components A and component B are working, and let's denote the lifetime when they're starting the experiment, the lifetime as X and Y. Okay, so now, of course, this X and Y both are continuous random variable. That's what they are saying. But as I said, that clearly they're dependent. They are not independent. Clearly they're dependent. And so we have 3 different cases which can occur. And the cases are that both of them fail simultaneously, A and B. So clearly we'll see this one that X is equal to Y in that case. Okay, both of them fail, so X is equal to Y. Or you can see this one that one of them fails. So suppose the component A fails, but B does not fail. But what is going to happen? The lifetime of A, since A has failed, so anyway, you observe that one. But since A has failed, the lifetime of B, whatever you had it before, it got changed. Okay, it got changed, the lifetime. So what you are assuming this one, that previously the B has the lifetime Y, and now it has changed to Y star. Okay, and then eventually, of course, B fails and the system stops. Then the person becomes completely blind. So that's what it happens. That one of the components, say for example, the A fails, so the lifetime of B has changed from Y to Y star. So we have to take care about that one. Exactly the same thing the other way also. that, well, suppose B fails and A does not fail, then of course the lifetime of A has changed from X to X. Okay, so these are the three possible scenarios. Of course, in all these cases, the censorings are there, which can be taken care easily. So I'm not going into that detail. So censoring can be taken care quite easily. So let's not put it here, which can be done easily. Okay. So now these are the three possible scenarios. What you can see that at the end we are observing this y1, y2, which is at the end we are observing. So now this y1, y2, which can be xy, that means when x is equal to y, both of them fail at the same time. That's what it is. Or first one is fail, and the second one did not fail at the same time. So it has changed to y star. So it has gone from x, y star. That's what you are observing in the second case, or you are observing x star. Okay. So these are the three possible scenarios. What you'll be observing. Of course, in all these cases, as I said at the beginning, that can be censoring, but I'm not necessarily not making it complicated, which can be easily taken care. So basically, now I have to keep this in mind that these are the three possible scenarios what we can observe. Okay, so let's see. So how we are going to do this one? Well, so these are the three things you have to take care. You have to look at that how x and y are related. That I think we have to look at that. How x and y star are related, and that you have to look at it, and the same thing at x star and y. Okay, so these are the three possible scenarios I have to take care in the model. The three possible things we have to look at it carefully. Okay, so before going into this one, again, as I said, that one of the important things that we have to take care that there is a positive probability that x is equal to y, and since most of the usual bivariate distributions do not try to take care about this one, so we have to look at it in a slightly different way, and this is actually one of the most famous bivariate distributions. What we call this one as a singular component, where probability x is equal to y can be positive, which was first introduced by Marshall and Olkin way back in '67. Which was mainly for the exponential one, but which can be generalized in a very, very general setup. And we call this one as a proportional hazard class model. So that's what you are trying to introduce. That well, if you're looking at a class of distributions, S of x lambda, which has a survival function, which is in this particular form, that x lambda is of the form of sbx to the power lambda. And this sbx, which is the baseline survival function, it can be any survival function. It doesn't really matter. I mean, although I'm just sticking to only on the positive one because that's what our application is, but it is need not be actually. There is no need that it has to be only on the positive one. It can be the entire real line, but in our application, since we are mainly interested about the lifetime distribution, so I'm just sticking to only the lifetime distribution. So my baseline survival function is SBX. So any that particular class, that SBX to the power lambda for any lambda greater than 0, and it can be easily seen that this one is also a survival. So I have a class. I have a class of survival function, which is SBX to the power lambda. So basically what I do, I just vary my lambda to get that class. Okay, and we call this one as a proportional hazard class with the baseline SB and the parameter lambda. Okay, that's what we have. And so now I go to the same formulations as it has been done by Marshall and Olkin instead of exponential. I am looking at this in this general one, and what I'm doing it here. That I'm taking 3, U1, U2, U3. All of them are independent. They have the same baseline, but they have a different lambdas, lambda 1, lambda 2, lambda 3. And what I'm looking at is that x is equal to the minimum of U1 and U3, and y is equal to the minimum of U2. That's the way I am putting it this one, and which actually makes, as we can see, that although U1, U2, and U3 are independent, but x and y, they are clearly dependent because of this U3. I call this one as a bivariate proportional hazard with baseline SB and the parameter lambda 1, lambda 2, lambda 3. The interesting part is that here both x and y, if you take your SB as a continuous one, your both x and y, they are absolutely continuous marginally. Okay, but if you're looking at x equal to y, there is a positive probability that they are greater than this. Okay, so that makes it that makes it what you want actually. Okay, by the way, it is a joint survival function which can be easily seen. It's a simple thing. The joint survival function looks like this, and what is important here? Yeah, so that's what it is important that there is a positive probability that x is equal to y. Okay, so there is a positive probability, although your x is, if you take your SB to be continuous, your x comes out to be absolutely continuous, y is absolutely continuous, but there is a positive probability x is equal. Okay, so this one what we want. We want one more thing, as I said, because what I want that when there is a failure, the lifetime of the other one changes. So that's what we are trying to follow. What is called this in the literature. There is a huge amount of literature. They call the step stress model. What does it do? You just try to model the hazard function, and so what it happens, this one, that the hazard function of a particular distribution, it basically characterizes the distribution function. So it has two components. Up to the time point tau, it has ht, but after time point tau, it has multiplied by some alpha. So as we can see that depending on alpha, if you choose alpha greater than 1, that means basically you are making the item fail quickly. Okay, that's what you do. Okay, if you have alpha is equal to 1, it's not going to change at all. If alpha is less than 1, you are making it delay. The probability of failure gets delayed. Okay, so that's the way we have my HT. So now based on these things, I have to trying to use both these things. So the way what we are doing it here, we are looking at this x and y, which is a bivariate proportional hazard, which guarantees that probability x is equal to y is positive. I am looking at the hazard function of x star, given that x star is greater than y, because y has failed at the time point A. Because of that, my x has changed to x star. So that's the way I'm putting the hazard function, which is in this form. And this delta basically, delta greater than 1, makes it harsher. That's what it is. And similarly, the y star, given that y star is greater than x, the hazard function, that's our. Okay. So now, as the hazard function is completely characterizes the distribution function, so based on these things, we can obtain actually the joint density function. Can be obtained. Some calculations is there. So what it is important here, that when your y1 equal to y2, then the hazard function, the joint density function looks like this. There is a positive probability that y1 can be y2. If y1 less than y2, then the joint density function of y1, y2 looks like this. And when y1 is greater than y2, the joint density function is this. Okay. So you can see that I am keeping the baseline completely arbitrary. Okay, I'm not doing anything about the baseline one. So it is true for any baseline survival function. So I can choose my baseline survival function. Only thing you have to keep it in mind, the natural thing comes that, well, you want to choose your SB completely non-parametrically, but then it is not identifiable. Okay, so you have to be a little bit careful about that one. So you cannot make it completely non-parametric one. So of course, the next thing is that close to the non-parametric, which is the semi-parametric one, and that's what we are planning to do. You can choose exponential Weibull, but actually you can choose the very, very flexible one, which is a piecewise constant. You can make it more general, but this piecewise constant actually works very well, because you can make this, coming to this one, the piecewise constant hazard function, which basically being characterized by the number of cut points and the position of the cut points, okay, which makes it almost like a semi-parametric approach. Okay, so if you keep both of them flexible, that makes it a very, 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 very flexible distribution function. That's what it is. So the piecewise constant hazard function, which basically can be represented like this. As you can imagine, that one, that I mean, suppose you are having lifetime distributions, you have model of this one. So you basically choose small cut points. That's what it is. So that's the way you choose your baseline hazard function. Okay, the piecewise constant. So you are keeping your capital N to be arbitrary, as well as your tau j's, which are the cut points. That is also to be arbitrary. That's what it is. Okay, and of course those things has to be estimated. Okay, this is I think one of the key issues. The piecewise constant one. It's a very flexible one. It can take variety of shapes. That is true. And when the number of cut points and the positions of the cut points also are known, it almost like a semi-parametric model. That's what it is. And I think the most important part is the last one. See, most of the time we assume some of the parametric distributions, but the main problem is that means you are assuming the shape of the hazard function. It's increasing, decreasing, constant, blah, 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 bus stop shape. But here it's a data driven. Okay, so you do not choose at the beginning. So let the data decide. So depending on the data, it will choose increasing, decreasing, bus stop shape, whatever it is, it will choose. We can make it more flexible. I'm coming to this one, but what we have seen this one that this itself is enough. Actually, you do not have to go for a more complicated one, more complicated one. So, so this is, I think, one of the important things. Although this piecewise constant hazard function has been there in the literature, but I think one of the point which has not been addressed about the position of the cut points and the number of cut points. Okay, so to do these things, to estimate those things, and as you can see that if when your aim becoming larger and larger, it becomes a very high dimensional optimization problem. Okay, so you can see this one that suppose your m is equal to say 5, and as you can see that 5 plus 3, almost like 8-9 dimensional optimization problem. Well, I mean, in today's world, you might be saying this one that 8 is nothing. That is true, but yeah, I mean, but at the same time, I think those who are working with this, even with the 8 or 10 dimensional optimization, we know this one that the choice of the initial guesses and all these things really make a difference. Okay, so that is one of the things. So the way we have addressed this one, we have taken is a slightly different approach. For a fixed aim, so the number of cut points I'm assuming it to be known for the time being. Later on, of course, we have those standard way using this AIC, PIC. I can take care about that. But assuming that the number of cut points to be known, I am assuming that the position of the cut points they're coming from a non-homogeneous Poisson process. Okay, non-homogeneous Poisson process with the intensity function delta t to the power delta minus 1. The idea came because, see, in the literature, most of the time, the way it has been done by assuming that the position of the cut points are equidistant. Okay, the positions of the cut point are equidistant, which is actually a special case of this one, because if you take a homogeneous Poisson process, then the position of the cut points comes out to be the expected value of the position of the cut points is equidistant. So the way it helps, actually, the whole thing just boils down just one parameter. Okay, so the whole thing now boils down to one parameter, delta. So for a given n, you basically have to take care about the delta, which will do the thing. So since my position of the cut points are unknown, so we are replacing by the expected values, and yeah, those are the joint density function of the position of the cut points, and you can easily obtain the expected values given the number of cut points to be m. You can easily obtain the expected values of those things. So you put this one in the latter. You put this one in the likelihood function, and then you have an extra parameter delta, which basically takes care about that. Okay, so that's the way you reduce the number of the dimensionality of the problem significantly. It doesn't matter what is your m. That's the way you just basically introducing one parameter. That's what it is. Yeah, as I said, in the likelihood function, you put the delta, and then you try to maximize. So finally, what happens? This one that it reduces significantly. And of course, finally, you choose your M based on the AIs. Okay, and it works quite well actually. Okay, so now when it comes to this specific problem, what we are trying to do, we are trying to see that whether the two treatments are significant or not. So that means what we are trying to test basically lambda1 is equal to lambda2 and lambda4 is equal to lambda5. That's what it is. And the alternative is at least one is different. That's what it is. And what based on the data what we have observed, that we cannot reject a null hypothesis. That means there is no significant difference between the two. Okay, that is one part. And the second question, what we are trying to answer, that whether the effect that when one I become inoperative, whether it affects the other one or not. So which finally boils down to test basically the delta is equal to 1. So which finally boils down to delta 4 is equal to delta 1 plus delta 3 and delta 5 is equal to delta 2 plus delta 3. At least one is different. And in this particular case, it turns out to be that yes, there is a significant difference in reject the null hypothesis, which basically tells you that, well, yes, it affects. Okay, if the one eye became operating, the lifetime of the other eye changes. Well, I mean, we do the routine this Bayesian one also, which has a taking it quite a bit of flexible prior, which is known as the normal prior. We have done that one, and well, we've taken a quite flexible one, and based on the almost non-informative prior, what you have observed that we have got the same conclusions. Okay, so I think with this, I think I'm stopping this one. Thank you.
Thank you, sir. That was a nice talk, but I would like to now open the floor for questions. If anybody has any questions.
So, I was just wondering about the problem that you are solving, specifically the data that you are having. You said that there are lots of covariates, and I think there should be some information since it's related to eye.
Yeah.
It should be something like whether the person is diabetic or not.
Exactly. That's what, yeah. One,
And you also have
that's the condition of the eyes, which is basically that.
There might be some other conditions also, some other chronic disease or something like that.
Yes.
So I was wondering, like, with this framework, I mean, if you can really address or answer the question in a better way, considering some kind of latent class modeling, where you might have the individuals clusters depending on their chronic disease or different health conditions.
Yes.
And then you can see the same type of hypothesis of the test.
Absolutely.
And that can give you some more insightful.
That I completely agree with you, Kirma. Yeah, that's what actually you are doing it, and we are clustering it actually. Yes, absolutely correct. Yes.
That you can do.
Yes, and particularly I'm telling you this one. I mean, the information what we have, I mean, which is basically the diabetic, which is the type 1 or the type 2, and there is a significant difference.
Yes,
there is.
So all these things. I mean,
Yes, exactly.
And my second question is that regarding the proportional class model that we are considering. So given the data, is there any way that you can actually statistically test whether this model should be appropriate for the kind of data that we have? Or, I mean, intuitively it makes sense, but is there any statistical test that can actually tell you that this is quite
See, without the, see, of course, see, if you go back and if you're trying to look at your the usual the bivariate distributions, we have a couple of tests, but we have to be a little bit careful whenever it comes to censoring.
Yes.
Okay, whenever it comes to censoring, I mean, yes, I mean, it can be taken care. It can be taken care of that one now. Yes, but that's a good point. Although we did not do that one, I think we should have done that one. But that can be done. That can be done. But we have to be careful about the censoring part. Yes.
Thank you.
Yeah. Yes.
So I was wondering that if so we can derive, so we have the marginal distributions, and based on the data from one eye, can we build a Kaplan-Meier type of structure and replace the SPs instead? Will that pose any problem, or is it not feasible in this?
No, can you just repeat?
So yeah, we replace SP with the corresponding Kaplan-Meier distributions. Then that would make
No, see, that's what I think, what is the problem, what is going to happen, that if we make it completely non-parametric, okay, then it is not an identifiability. Identifiability problem will come up.
But will there be any conditions that we can satisfy to make it identifiable or?
Should be possible, but we have not thought about that. Yes, I think,
Earlier we worked with this piecewise linear, but the problem that I face, but now we have addressed that reducing the dimension. But again, the choice of M also is a factor because I went up to N equal to 7, but still I don't know if that is the best choice of.
actually, in this particular, of course, it will depend on data, but in this particular case, we got N is equal to 3. I mean, that is there, but yes, that is a problem. Of course, that is a problem. But I don't think that problem, it will be much reduced if you go for a completely non-parametric. I think that will be, yes. And that problem will be, I think, more complicated there. That will be more complicated there. Yes.
Is there any other alternative to these choices like full parametric or piecewise or complete non-parametric?
Well, say people are, say, sometimes people do suggest, I don't know whether it will make it easier or not. Say one of the things you can go for a spline. Okay, that is one thing, but still the number of parameters remain more than the constant one. Yes. Yes. Yeah.
Am I audible?
Yeah.
So you have a sensor data,
Hmm.
but there is also a left sensor in that you are kind of ignoring, is it not? Like when the person was diagnosed or when the person actually had diabetes, from then when they actually come to and start the treatment.
Okay. I think I got your point. I think I should have mentioned it from the beginning itself. Here, the time that the data which has been reported, which is basically from the time the experiment starts. That means when they are giving the treatment. Yes, yes. So it is the time, that's the time.
Your conclusion is that the treatment has no significant effects, right?
The
But
data treatment did not have any significance.
But it may also depend on at what progression the treatment is given.
That's a covariate thing.
But is that also taken into account in this model?
See, the thing is that since we did not take care about the I did not present in the covariates one. So once the covariates comes into picture, those things will be.
But even after taking into account the covariates, it turned out that
we have not done it. We have not completed that. Completed. Fine.
So if you had 2 or 3 very unusually large lifetimes, so how stable would the probability be?
You can go for the robust one.
Does this have some natural?
In this particular one did not have. This particular one did not have. I mean, see, actually, one of the reasons for this one, I mean, most of the patients came when they are quite on the severe, close to yes, quite on the severe. But definitely in any other applications, yes, there is a possibility. I mean, we have to think about some of the robust. In this particular case, it did not have. All of them actually.
This data did not have that problem.
No. This particular data did not have.
And also about this hazard function, so you are taking it semi-parametric, because non-parametric is not working. Fully parametric hazard functions are also possible, right?
Yeah. See, for example, exponential y group, that's what I have. Yeah. Yes.
And that can also be determined from the data which one seems more plausible.
Yeah, definitely. But see, the thing, that's what I said. I mean, see, if you choose, say, for example, it's a y group or long normal and things like that, that means before even fitting the data, you are assuming this one that is an increasing hazard function, or it's an bathtub say function, that is total hazard function, which we do not need if you go for a piecewise function. Which data should be silent. Data can be silent. That's the evidence.
So in the semi-parametric setup, is the piecewise constant the only available real option or?
No, that's what I said. I mean, we have other ones, for example, the spline one. Yeah, definitely you can go for a spline one. That is definitely option, but again, that makes the things computationally more able.
So in that case, maybe penalized likelihood would be a better approach.
See, in one way, you are doing the penalized likelihood in the sense when you go for the ICDIC, you are doing the second data. Number of when you are taking that one. Yes. That's, yeah. Yeah.
In your model, the hazard function changes when one of the I fails. The hazard function is
Yes. When the other.
the other I. But what if both X and Y are censored? Then
No, so when both X and Y are censored, say for instance, that also can be taken care because see, then there is no change in the hazard function. So when both of them censored at the same time.
but in the future, because we have a censored observation, that we observe the data for infinite time, at some point one I will fail. And then the hazard function for the other I will change. So how we are incorporating this?
No. See, the thing is that here the censoring, the way it can happen, that none of them fails, but both of them censored at the same time. That's what, and that can be easily taken care. That can be easily taken care because, say, you have the survival function, and we know this one that when both of them fail, X is equal to 1, and they have censored. Okay, so basically X plus is equal to Y plus.
Yeah, but when we are saying X plus is equal to Y plus, we are not considering the change in hazard function in the future.
Yeah, but that data we do not have. I mean, whatever data we have, that's the only information I can give, isn't it? The only thing I know is from that, both the survival function of both the i's are more than that quantity, and that can be taken care from the survival function of the.
So then basically we are, our assumption is till the observed point of the data, the hazard function remains same.
That's it, definitely, yeah, definitely, yeah. So hazard function changes only if the other I fails, which you do not observe in that particular case.
Thank you for the engaging discussion. On behalf of ISRU, we sincerely thank Professor Devashish Kundu for his enlightening lecture and for being part of the celebration today. We shall now break for high tea, arranged at upstairs, 4th floor ISRU. Kindly reassemble here at 12:30.
মানে আমি আর ফ্রি যদিও ট্রেনের টিকিট
কল্যাণীতে জয়েন তুমি কল্যাণীতে জয়েন করতে এখন এখন কল্যাণীতে কত এখন 400 জিরো থেকে 4 বলে হিউজ চাপ দেখলে
একই জিনিস অনেক এসছে একটা মানুষের থেকে আসতে পারবো ওটা রুমটা একটা ওটা গেছে ও স্ক্রিন হচ্ছে
খেয়েছো তো তাড়াতাড়ি করে খেতে গিয়ে আসলে চিন্তা কেটে গেল তাড়াতাড়ি করে খেতে গিয়ে তাহলে কি হবে কেটে গেল পুরো রক্তে লাল হয়ে গেছে জল খায় মনে হচ্ছে লাস্টে লাঞ্চ টাইম আমরা এমন আরামকে খেতে দিয়ে কথা বলতে বলতে খাচ্ছিলাম ওই নিজে দাঁতে কেটে
নিজের দাঁতেই সবচেয়ে বেশি কাটে।
আমার
Yeah, I don't know what they're doing. Just call someone and ask that person. Futhi, Futhi, he's here. I'm really আমি বলে দিচ্ছি বলো কি otherwise we will get late. Otherwise we will do something. এখন আর খেতে হবে লাঞ্চ এর সময় লাঞ্চ অ্যাকচুয়ালি এটা আগে করলেই ভালো হতো 11টা শুট ওটা একটু দেরি হয়ে গেল বলে ঠিক আছে আর টকগুলোর আগে লাঞ্চ টকগুলোর আগে ব্রেকফাস্টটা হয়ে গেলে ভালো
ওটা বর্ষা পাইনি।
লোকজন বললো লাঞ্চ করতে তো এনিওয়ে দেরি হবে তো 11টা এখানে দেরি হয়ে যাবে 12টাই ঠিক আছে ঠিক আছে চলো শুরু কর
wait for they are coming maybe wait for
কামিং মানে কি বিকাশ করে রাখছে না
এখান থেকে এইখানে আসতে আবার
হ্যাঁ উপরের দিকটা কমিয়ে তল দিকটা বাড়াচ্ছ নাকি তোমার প্ল্যানটা কি
Welcome back, everyone. We shall now resume the academic session.
with our next invited talk. It is my pleasure to introduce our next invited speaker, Professor Shivashish Dasgupta from the Chatterjee Group Center for Research and Education in Science and Technology, TCG Crest, Kolkata. Professor Dasgupta is an distinguished researcher and academic working at the interface of statistics, data science, and machine learning, artificial intelligence. He previously brought his expertise to Pfizer and Ford Motors, and he currently serves as professor in artificial intelligence and machine learning at the Institute for Advancing Intelligence, TCG Crest, and has played an important role in promoting interdisciplinary research and education in data and statistical sciences. His work spans statistical modeling, inference, machine learning, and their applications to real-world scientific problems. He has also been actively involved in academic leadership and mentoring through various national institutions and professional bodies. We are incredibly lucky to learn from his unique blend of corporate and academic expertise today. We are delighted to have him with us today, and we look forward to your talk, sir.
Thank you. Thank you. It's a wonderful experience after a long time, and thanks so much for inviting. When I first went to US for doing PhD at the airport, my came to pick me up. I still remember, a long time ago. Then when I came back to India, I was in ISRU for some time, and that's so I was like, looking for Amitaji, but I heard that she's in the US. It's a great pleasure to come back here, and I can see lots of familiar faces. I came back to Kolkata very recently after a long time, and hopefully, I will be having a great experience in Kolkata. And this is a new institute. It's a kind of a startup for me. I was in big companies, Ford and then Pfizer, two different domains, automobile and then pharma, and then again coming back to academia, but not a typical academic institution. This also has a corporate structure. So let's see, it's a kind of a startup, very new. We only have PhD program established. We don't have master's program yet. So I have lots of responsibilities to build the institute, and so looking forward to it. And I'm also an adjunct faculty at CMI, but that's for a long time, because when I was in Chennai working for Ford, I used to teach at CMI because Professor Karandikar was there, the director, so he requested me to come regularly and teach there. And so we had a very strong relationship, and I'm continuing that. So I don't teach because I have to be in Chennai for that, but now I'm in Kolkata. So great. So this is a talk basically from a statistical learning perspective, and also from the work that I was doing at Pfizer, which basically will continue a bit. The only problem is when you leave the company, you lost the access of their rich data. So that is one problem I am facing, because unless, though I have a very close connection with Pfizer and Ford, but they have lots of strict rules and regulations to access the data. Unless we have that intellectual property right and that non-disclosure agreement, all those things, in academia, it's very difficult to get that type of data, where in industry they have, specifically for great companies, they have very old company, right? Pfizer is 175 years old, Ford is 155 years old company. They have lots of data. They have huge establishments, right? So that data richness is there. Where I am feeling that in academia it's difficult to get access that type of data. So we have open source data and other things where we need to see where we can fetch the data. Anyway, this is a joint work. I was leading this project, and I had one team member, and one, of course, my Russian colleague Vladimir. Me and Vladimir working for a long time, and it's a kind of Bengali and Russian, collaboration. So So the roadmap is of course usual. I can tell you the background and goal. I cannot show you the data because again that's data confidentiality. Even if I was in Pfizer, it was difficult for me to show the data exactly because there are lots of data confidentiality. But I can give a overview. Okay. And the algorithm and then the stability of which solution, I will talk about that, and the framework, and then evaluation criteria, and then application to clinical trial data, and then summary and conclusion. Okay, usually it's a variable selection problem, and all we know that if we have lots of variables or covariates, features, whatever we call it, and the outcome. Okay, so we have xi, yi, we have sample n. But the problem is sometimes in the clinical trial data in pharma industry, it's a very, very common problem where you don't have much sample. The n is not large enough. So that's a very typical problem. N is not large enough. And on the other hand, the dimensionality is high. This high dimensional low sample size form, HDLSS. Okay. So, but the problem is inferential problem, right? Because you don't have enough data to make inference. You have high dimensionality problem. But on the other hand, you need to select which variables are significant, which variables are impacting the outcome, right? So that is the goal. It is not that the prediction is the ultimate goal in this domain. The ultimate goal is inferential. Which variables are significant, which variables are impacting. So selection of those significant proteins or significant biomarkers, whatever we call, okay, depending on the disease outcome. Okay, so and on the basis of that, we can build the right, like we can identify the right population for the right therapy, because there's a clinical trial, and the clinical trial involves a lot of not only just money, lot of time and work and all those things. So we need to design the clinical trial efficiently and effectively. For that reason, variable selection or feature selection is very, very important. There are different algorithms, but the thing is, depending on the problem, we have to try some of the algorithms, and there are also, different things that we need to try, we need to explore. But we cannot say that this is a very difficult problem. It's not that you are always going to get a very nice result or satisfactory result, right? So basically, if you look at the feature selection algorithms, then you have different kinds of, if we categorize all those filters, wrappers, and embedded systems. For filters, we have MR, that minimal redundancy maximum relevance that we have used. We have tried to see how it performs on that typical data. And their wrappers method, we have basically SVMR, if you will. SVM topographic machines is the main modeling framework. And then using SVM, we need to select. We have genetic algorithm, we have other thing. And embedded, of course, from a statistical learning perspective, we have that penalized likelihood methods like lasso, elastic method, or tree-based method. The thing is, we have used different algorithms, but here I am going to focus two interesting algorithms. One is MR, minimal redundancy maximum relevance, and the other one is wrappers, because there is a computational efficiency problem for some of the other algorithms, and the other problem, of course, sample size is very small. So it's not that all the well-known algorithms will give you a bit of satisfactory results, right? Okay, so the wrapper approach is basically we have to greedy search approach. So you have for kind of try a feature set and evaluate the model, and again until you get the satisfactory results, you just iterate. So it's basically from a very statistical perspective, we have learned that so long time ago, that is basically stepwise, or you have backward elimination, you have forward selection. So all those concepts are there. So people cannot just say that in machine learning on AI, everything is very new. So that is the main problem nowadays I am facing with working with different people that many many algorithms are coming up each and every day, and they are saying it's very new, but they don't know that long time ago in statistics, many things are already very well established. So that is the main idea that we need to convey as a statistician to the people who are coming from other fields, right? So that is one thing. Okay. SVM is of course a very popular algorithm for classification and aggregation, and we all know that we have two classes, right? And then basically we need to maximize the margin, and that is an optimization problem. Public introduced that, and then of course statisticians also use that heavily. And we have examined in statistics literature, we have examined also the optimality of SVM classifier, right? So in linearly separable case, we can have in that dimension where we have the same dimension, we don't have to map it because linearly separable is a bit easier to handle. We can introduce a penalty for any wrong or misclassification. But when it is very difficult to separate, then you have to map it to high dimension. And in high dimension, it is a bit more separable. So that is the idea. And you know that we can use Carnot trick to do all those things. So and SVM is just basically very much applicable in some of the situations that I faced. Not all the situations, of course, it depends on the data. Again, the data is basically guiding us that which approach is better than the other. It's not that there is only one algorithm and people can say that this is the best algorithm. There is no such thing in this type of problem, right? So basically all models are wrong. Some are useful, so, and few works that I can add. So that's the thing. In practitioners' perspective, what I saw in real life, different type of data that very difficult to analyze some of the real data. Even if you have known different algorithms, you have the toolbox, but not always all the algorithms or modeling framework will work, right? So this is the input space from feature space, and then there's optimal hyperplane in the feature space, and you can kind of efficiently separate the two classes. Okay, so that's the idea of SVM. And from a decision theoretic approach, we can see that SVM approximately target the Bayes rule, which is basically the optimal rule, right, for this type of for the classification problem. And that is coming from statistics literature. We can pass the whole optimization problem in a regularization framework, right? And then we can also show that SVM optimality, right? So it is minimizing the classification error rate. And where Vapnik in 98 showed that the test error can be reduced, and all those there is a bound, upper bound, and then we can minimize the bound. So all these things we have, but that is coming from a statistical perspective. When it first came as SVM as an algorithm, it was all a kind of a heuristic in nature. But then all the statisticians work on that, and they have given a very solid foundation in all those algorithms. Though the algorithm might not come out from proper statistics field. So Vapnik is a mathematician, I think, so in Russian mathematics. And they have that statistical learning theory from that perspective is a bit different than usual statistical inference. But they have a very strong connection. We cannot just say that something very new is coming in the age of AI. So what is important is statistical thinking in the age of AI, right? Okay, so then the idea is support vector machine recursive feature elimination using SVM, and at the same time using the traditional statistical method because it's elimination problem, how to merge those two things and come up with an approach which can give you the idea of how to effectively handle that type of data. So basically, it's a backward elimination strategy, and the full model is created first, and then the you have the measure of variable importance, which SVM can give you the weight for each. Even if it's high dimension, SVM can bypass that problem. Even if it's a low sample size, SVM can give us that support. We don't face that type of problem there. And at the same time, we can also use that backward elimination to see that which variables, which proteins, whatever is coming up, and we can kind of identify all those things from an inferential perspective. And also from that, we can also go ahead a bit and try to see using those selected variables if we can predict the outcome, and that is for the evaluation purpose. But our focus is not just prediction. What I saw in the other fields coming, which are basically AI or engineering, they are very much focused on prediction. All problems are not prediction problems, right? All right. So there's a huge inferential, deep inferential problem built it, which basically lots of people who are coming from other background, they just want to ignore, and that is not a very good sign to just ignore all those things and just do the prediction and see and show the world that hey, see, this is the wonderful prediction we have done. This is a competition. Something is going wrong that we need to address. As a statistician, we need to address. As I told everybody, that without statistics, data science is not a science. That's the most important thing. The science of data science is statistics. Okay. Now coming to a different type of algorithm, which is the motivation is mutual information. Again, people can talk lots of things about mutual information. This is also a clear divergence law. That the idea of coming from, right? The clear divergence laws. So we have lots of variables as X, right? And your outcome, and you can use that information criteria to see how the dependency works from one variable, the explanatory variable or feature, and then the corresponding outcome. When it's zero, that means it's kind of independent, and when they are identical, that's flexible. So we use that the tail divergence law where we have all the information. So using that mutual information, we can go ahead and see this algorithm, the minimal redundancy, maximal relevance. So if you look at that, this MR is highly efficient in a sense. This is not computation that much intensive when you have a low sample size and high dimensional problem. And so it helps us a bit more to experiment with this algorithm. And here you can say that the idea is very simple also. So at each state, it calculates the feature with the maximum score among the remaining unselected features using either difference. If you look at that difference, it's very easy to understand, right? There's the first one, basically the dependency association between one particular variable with the class, and the other one is the neutral thing, and you can already. So idea is basically is this kind of focusing on this inner circle where we want to penetrate here to access the minimal optimal subset. So sometimes the problem is we have all relevant subsets, but if we have all relevant subsets, we also have some kind of problem in the modeling framework. So there are some variables which are not that much impactful. And in that case, it can increase the complexity of the model being framework because you are already having a high dimension. So you have to reduce and focus on which proteins are actually creating that particular type of cancer, right? So that is the thing. but so basically the idea is to find out this inner circle and from the whole set, how we can access that. It's not very easy, but we need to see from different perspective how we can go ahead. Okay. So here at least I can show you the two algorithms. There are different algorithms we can work, we can talk, but for a particular problem where we have used and focused on these two. So mainly MRMR, which works iteratively, selecting one feature of that protein at a time, and at each step, it selects a feature with a maximum score among the remaining unselected features, either the relevance minus redundancy or the division portion. This algorithm was developed in early 2000 and got famous in Uber. They have used it in their, that feature selection problem the Uber app. And the other one, of course, based on NCM and it's backward elimination strategy. The full NCM model is created. It will show you, give you the weightage, and then slowly you can cut off the unimportant, unsignificant values, and then you can go ahead. Okay. So coming back to the stability, why stability is important, particularly in this type of data, is that sometimes what happens, you use that algorithm, you find out the significant one, but you need to repeat the process. It's not one-time process, right? You need to see whether that algorithm is stable or not with respect to the particular data. The stability idea is very important. It is not that you can just blindly use an algorithm and get, tell me which variables or which proteins, which biomarkers is important. Why stability is important? Because if you change the data, if you kind of suppose in a clinical trial process is a long process, like sometimes it might happen that the data might change a bit, right? Or there might be some problem. In that case, that same algorithm might not give the kind of similar results. So it's very unstable in that nature. So why should we rely on that particular algorithm which is not stable, right? Even if it's giving a very satisfactory result, we cannot trust that algorithm. So we need to implement or incorporate the stability idea that even if it's basically in the small sample size problem where you have small and large field, this is very, otherwise we cannot just go ahead blindly and choose that significant variables. But like how to quantify that stability idea, how to incorporate that stability idea in those algorithms, and then how to kind of build a framework for this type of data, of this type of problem, right? So that is very important. So how useful are the selected features, and then how sensitive are the selected features to small changes in the training data. So we need to experiment it multiple times to see that for the particular algorithm, how we can focus and coming to the same type of variables. How do you need to repeat the experimentation? The implications will give you, and then the stability idea we need to incorporate, and that is a novel stability measure there in a journal of machine learning research, and that idea we try to incorporate in those algorithms and try to see if we can find out that. Oh yeah. So here it's also very simple. Suppose you have only 6 variables. Suppose you have 6 variables, and then you have that matrix where 1 means that variable is selected, 0 means not selected. You need to have the bootstrap samples, right? Multiple times. You generate the bootstrap samples, and you can see that same algorithm you can apply, and then you can have that type of matrix, and then you can have that bootstrap covariance, right? Using that bootstrap covariance, we can have that novel stability measure to identify how much stable that algorithm, right? And that we can incorporate first to find out the optimal number of variables. That is basically, we're saying K is the optimal number of variables. So to find out that, we need to use that. And you can see that this bootstrap covariance matrix, you can see that if it is very high, that means there is a problem. Then for that particular variable, then is even the algorithm is selecting that is not stable. For all those bootstrap samples, it might be there is some problem. That's why the bootstrap sample covariance is basically getting that high value. We need to incorporate that idea, and then we can have a framework where we have the data set. We need to divide it. So basically, it's a very conventional way that cross validation we need to do. Otherwise, even if it's small sample, we have to do. There is again problem because you have very small, sometimes very small sample. So it's very difficult. And then again, in the AI world, people are saying that we need to have big data. Every data is not big. That is the main problem. Every data is not big. And we cannot do it in this type of domain. We cannot artificially generate the data is very sensitive, right? In this type of domain, you cannot just artificially generate and involve all those things to get a large N from small N. In reality, you cannot just blindly go ahead and have that large N using AI. There are lots of work going on, but that is not trustworthy. So because that's why when you are going to do the work, sometimes the main problem is the regularization. That regularization, what is happening there, that gives you some unstable, unreliable results. And these domains are highly regulated in nature. You need to show whether it's stable or not. And in that way, when you are filing any vaccine or any drug, it's not being accepted because you have to show the solid background that what is going on. You cannot just show a black box because it's highly sensitive. Right? So in that way, we can have that bootstrap sample and then use that stability idea, and then you can find out the optimal value of A using that stability measure, and then you can just top 10 or top 20, whatever. We have to interact with the domain experts. The data is coming from the domain experts, and what they need, how many significant variables they need, that we need to choose, and that is up to them. You have to interact with them. And then you, out of 10, you can say top 10, the highly repetitive variables for each bootstrap sample is coming back repetitive times, but it's within a stability measure is there. So it's also the algorithm is stable. So you have kind of a balancing way of selecting those variables, and then you can just go ahead, build the model, and do the validation. Okay, coming back to, so this is the main flowchart. You have the features, and in that way, we can have the final selecting model. Okay, so there's two ideas, feature stability and then model accuracy. We need to get model accuracy is basically we are going to see how it performs in the test data. That's that. So this is coming the proteomics data set. You can see the phase 2 clinical trial data. We have only, very small body baseline as well as follow-up. So baseline is basically when the patients are starting, right? And then follow-up is after a significant amount of whether the treatment is working or not, that is the follow-up, right? So from using your baseline data, right? Using the baseline data, you need to find out those proteins which are basically impacting that particular disease. And then follow-up, you can get that outcome, whether that treatment is effective or not. So it's basically your model. That is you are getting from follow-up. So that's it. And then the number of proteins you can say, we can restrict the C16 because we have only taken that high dose patients. For low dose patients, it's not that much important. They are and then you can see how the P and N are important. So those are the for tissue as well as for serum, those are the variables. I cannot say the name, the exact protein name. Those are the confidentiality problem. So which proteins are actually, but we can just give a number that okay, protein number 1, protein number 2, and you can tell those proteins are coming, and those rates are basically highly repetitive, right? Proteins that the variable selection algorithms are kind of selecting. And this is the stability idea where you have that particular data where the stability is maximum for which optimal number of variables, where in this case it's 40. So basically 40 variables are kind of optimal in nature, but you might don't have to use for it depending on the domain experts. They can say that, okay, give me top 10, not 40, because if in that case 40 is kind of an optimal, you might not need. And then there are, this is also using SVMRC. You can have all those variables, which variables, and then at the same time we can always kind of evaluate the model. Evaluation here only because of to make sure the inferential structure is kind of a backbone or not, solid backbone or not. It's not that we have to predict something, but it's basically to see. And we can use any classification model as well, a random forest, to see that using those significant variables which are chosen from that particular algorithm, variable selection algorithm, how they perform when we have that kind of prediction. So at the end, the idea is this: a general feature selection framework has been developed for robust variable selection, incorporating the stability idea, specifically for the high dimensional low sample size. So this is very specific to high dimension. As I told you, that this type of problem might very frequently we face in this domain. Optimizing stability can be potentially achieved without significant loss of accuracy and can help identify the relevant underlying set of features. Now, this developed framework was successfully applied to the data for the phase 2 clinical trial. What in Pfizer, that phase 2 clinical trial happened, and we have to kind of identify and work with the clinicians, right? Mainly they are MD PhDs. They are basically working in the lab. In India, it's basically all in the US. In India, what I see, very few doctors are very involved in research. So that is, I think they are more in like practicing doctors. But there are MD PhDs who are totally devoted to their research. That's very lab science, how to wet lab they have and all doing that, all those things. So now this framework can be customized. You can have different algorithms you can see, but depending on the nature of the data, you can always work on. So it's not a kind of a Bible, right? It's you have to evolve with the nature of data. You have to evolve your algorithmic ideas and the framework to see what is going on, whether you are efficient and effectively analyze that particular data or not. This is not a universal cheat sheet that nowadays people are doing. There are a cheat sheet. So all those things. This is not the case. So we have to be very careful in each and every step and think logically and from a statistical point of view, whether those things are making sense or not, and at the same time interacting with the domain experts or clinicians in their language. They cannot understand our technical language, right? So in their language, continuously to get the knowledge from them, because we are not biologists, we are not medical doctors, right? I left biology at class 10. So, but we need to interact with them to understand a bit, because I cannot just read biology now and be an expert suddenly, right? So that is, it's a continuous process to evolve and to improve and to learn. Thank you.
Thank you, sir, for that wonderful lecture. The floor is now open for questions.
So, in the two methods that we MR, and that SVM. So that top 10 features we are getting from these two methods, are you getting the same feature?
Some of them are common. Where I like the red. Some of them are common. Even if they're two different algorithms, some of them are common. So this is basically the call will be taken by the domain experts that what they have the huge experience of getting the data, creating the data for the clinical trial. They can understand that basically which algorithm is giving the more sensible results. Yeah.
Suppose that if that in two of the methods statistically to understand that one of the selection method will give you the best accuracy.
Yeah.
And your doctor says that no, this is not the accuracy. If the domain expert says this is the actual one, and which one you suggest?
So of course, basically the thing is whenever we say that okay, this is the suppose this is one particular algorithm we're using and we're having those selected variables with the test data results. For each of the variables, they will tell us, but from their own domain expertise, that those results are making sense to them or not. Right? So we have to take into account their consideration. So here statisticians are kind of helping and supporting them, but they are taking the main decision to tell us that okay, I think this algorithm is better, even if it is not giving you a. That's why I'll tell you, prediction is not the ultimate aim here. The ultimate aim is inferential, and that people miss a lot nowadays. What I am hearing from different background that prediction is the if you have high prediction, very close. That's then basically that is the kind of a hit, super hit thing. So actually, in some of the cases, I will say that from my experience, in industry experience in different domains, that's always not the case. You have to work with domain experts, but because you, so as a statistician, data scientist, you are working with a different domain, right? You cannot be an expert of that particular domain, right? So you need to be connect with that, with those experts who are coming from a very different background.
Thank you for the engaging discussion. In the interest of time, we shall conclude the question and answer session here. On behalf of ISRU, with due respect, we sincerely thank Professor Dasgupta for his insight.
Thank you. Thanks a lot. Wonderful talking to you. Wait. Junior, junior. Yes. No.
It's my pleasure to introduce our next speaker, Dr. Arnav Hajra from the Department of Mathematics and Statistics of IIT Kanpur. Dr. Hajra is an alumnus of the Indian Statistical Institute, Kolkata, where he completed both his BStat and MStat degrees. We are especially delighted to welcome him back, as he was also associated with ISRU as a visiting scientist in 2018. His research interests include spatial statistics, Bayesian modeling, extreme value analysis, environmental statistics, and high dimensional data analysis. His work has appeared in several leading international journals, and he has made significant contributions to modern statistical methodology and applications.
By the time we start, so thanks a lot for the introduction. So just to begin with, like it's always nice to be at ISI and like meeting all the people and giving the talk. So I joined during the BStat in 2009, and then so back in 2012, so in the last year of BStat, so I started working with Professor Pavitra Bonik from the Agricultural and Ecological Research Unit. So initially I was mostly working with different types of environmental data, and he was working with agricultural data mainly. And I was trying to understand the basic things that time, not statistical things directly. And eventually, like I started working with more with him, and then later on, I worked with Professor Saurabh Bhattacharya from this unit, and then it was Biru. And so gradually, I learned the statistical sides of like how to work on the environmental data sets, and so that's the point I feel. I started mainly working on environmental statistics, and so since more or less from 2011 and 12, I'm working on that topic, and I really enjoy working on this topic. Okay, so thanks. Okay, so I'll just do. Fine to do control L, right? Or I skipped. Okay, fine. Okay, okay. So today's talk is about Bayesian latent Gaussian car-copula model for analyzing spatially varying trends in rainfall. So as the name suggests, so it's a Bayesian model, so it's a latent Gaussian model. So latent Gaussian basically means the hierarchical Bayesian model, and with Car's copula structure. So that's I will go into the so copula basically comes in the dependence modeling part, and then we are analyzing spatially varying trends in rainfall. So because rainfall trends can vary across a big region. So this is a joint work with my PhD student Sayan Bhumi. And so I come from the newest department of IIT Kanpur now. So it's the Department of Statistics and Data Science. And this project was supported by SRG grant. Okay. Okay, so briefly about the motivation and the data sources. So if you look into the climate structure of India currently, like there are in the same year we are facing droughts and flood both, and maybe in the similar regions also. It's not like drought is happening at one place and the flood is happening at a very other place, but at the same place actually both the things are happening. And one big area where it affects the most maybe in agriculture. So moving ahead, so this is one of the recent missions of the government, so National Mission for Sustainable Agriculture. So under this flagship initiative, so there are certain measures that have been taken, which emphasizes like the efficient water management, climate resilient farming practices, and drought preparedness and sustainable agricultural productivity. So it's more about if you have less water, then how to use that less water to grow more crops. So to that part. But one fact is also true that nearly 60% of India is still the agriculture is still rain-fed, means so it totally depends on the rainwater. Now, if the rainwater is like changing or unstable or have high uncertainty, then obviously it leads to a high uncertainty in the agricultural outcome as well. Okay, so a statistical motivation that's why is about the reliable rainfall modeling, so that can take care of the climate change and for like essential for support evidence agricultural and water resource decisions. So that's the aim. So the data set now, so that's the purpose. Now, a reasonable data set that we can work on here is the meteorological subdivision based data set. So India, there are states and UTs, but it's divided into 34 meteorological subdivisions, which were defined by Guho Thakurata and Rajivan in 2008. International Journal of Climatology. And based on that, so how that 34 regions, I will show you how those 34 regions are. And basically, IMD has around like 5,000 or 6,000 weather stations all across India. And from their district level data are accumulated, and from there, the area weighted aggregation is done to get the meteorological subdivision based data. Now, we are mainly focusing in this project on the monsoon season because that's the time when kharif crops are grown. And the data are obtained from this open government data portal, India. So this is more or less the data structure looks like. So these are the 34 meteorological subdivisions. The data are available from 1951 up to 2014. And as you can see that the western parts of India, except the Western Ghats region, receive quite less rainfall, and that's common for all the years. And the northeast obviously receives more rainfall compared to the other parts of the eastern India. And the data has some other features like, let's say, in 1991, so the data corresponding to this meteorological subdivision, which is Jammu, Kashmir and Ladakh. So that is suppose missing. So we have to also take care of the missing data as well. Okay. So from this data structure, one thing is clear that so the patterns are different across India. So they are not like the same pattern all across India. And at the same time, like you can see that here, for example, if you look at here, so the similar regions may behave similarly. And here also, like the similar regions behave similarly most of the time, not always. Like here on the border of the Arabian Sea, it's different. Okay, and missing data are also there. Okay, so let's start with the exploratory analysis. Now, first thing is like we want to build the model into two layers. So the marginal modeling part and the dependence modeling part separately. Now, why gamma distribution? So there are certain distributions that are mostly used for rainfall modeling. Like, and naturally, like rainfall is non-zero, so it's a monsoon rainfall data, so it's naturally non-zero, usually positively skewed and supported over positive real line. And but the one factor is that so out of such distribution, so gamma is generally always preferred by meteorologists. Okay, and there are some papers, like for example, this paper, the title of this paper is itself that why rainfall follows the gamma distribution. Okay, so that is one thing. Now, one thing also to note that if we pick the log normal distribution, the easiest part is that we can take the log and then we can model using the log of rainfall using a normal distribution, right? And if you can use normal distribution, then multivariate normal all of us know, right? So the modeling becomes much simpler. But still, log normal is not the best choice here. I will show why. And so before we show, so the gamma model, the way actually we characterize it, in some canonical form in the gamma regression structure, gamma regression structure. So gamma usually we know using say shape parameter and rate parameter. Now shape parameter, note that for every region of India, we need a separate coefficient. We cannot take same coefficient all across India. And at the same time, so this lambda IT is basically the rate parameter is varying across the regions and also across the years. But obviously some sort of parsimony is required. So that's why we are modeling the mean structure, the log of mean in a linear form. Okay. Now, obviously we do some like the covariate we adjust by centering and scaling. So it's a little bit change. But after that, note that, so the rate parameter just can be modeled as AI times BI times e to the power CI times T star. T star is the centered and scaled year, basically. Okay. One thing here that all these different parameters now represent something different. Let's say AI represents the coefficient of variation in some root AI basically, and BI represents the intercept related level, basically the overall rainfall average, and the CI basically represents the slope related. Basically, if note that, so this beta I, if beta I is positive, then we can say that over the year it is changing positive, right? And beta I and beta I tilde are like linearly related. So beta I tilde is also like if positive, then we say that rainfall is increasing.
Gamma C,
Gamma.
no, YIT is independent. No, yeah,
Here.
that's C.
C. So it's canonical form.
Oh, the canonical.
Yeah. So, yeah. Okay. So this gamma C basically is the canonical form. Okay. So I'm writing as the mu IT is the mean and AI is the shape parameter. And but usual notation is gamma AI comma lambda. So that's it. Okay. Now note that if the rainfall is increasing over the years, so that means beta I tilde would be positive. So that means CI would be negative. Okay. So that link we will use later, and that's the structure in the margin. Okay. Very simple structure, I hope. Now so then what we do, so we look into the QQ plot comparison. So for log normal and gamma. Okay, because as I said, like log normal would be very simplifying the whole problem, but we see that actually, I mean, so this blue line is for like gamma. So what we are doing, so suppose I am fitting a gamma, then I have the F hat, the CDF hat. So I'm evaluating the data at there. So it transforms to uniform 0, 1 basically. And then I'm looking at the quantiles of the uniform transform data and also the quantiles of the uniform distribution basically. Okay. So if these lines are closer to this dashed line, so then I would say that is better. Okay. So I see that more or less on an average. So this gamma remains much closer to this line. And so that indicates that we pick gamma from now on. Okay. So instead of log normal. Now, next thing is about the potential dependent structure. So whether there is any dependent structure in the data, because one thing, note that, so based on this gamma model, what we do, we first calculate the MLEs for each region separately without incorporating any dependence. And by the way, across years, it's simple to assume independence because we have just a monsoon period data for this year, monsoon period data for next year, which is like likely to be independent, right? Because they are coming from different years of like the events, right? Now, and but the similarity of the MNEs of the nearby region indicate the suitability for some car structure or ICAR structure prior. So we need some structured priors here. Why? Because note that, so there are certain regions. So if you look at here, so these are the MLEs of different regions and they show some similarity across space. So it's not like suddenly, I mean, one region is having drastically different pattern from its neighboring region. There may be cases, but not everywhere. Okay. So we can, there are some measures to like look into the association, the spatial association. So we look into that. And what we find that after like transforming the data to uniform faces and everything, so this Moran psi of the transform data turns out to be quite high with a negligible p-value, which indicates that even after I consider a structure in my priors, so then also there are dependence in the data. Okay, so I need to model the dependent structure in the data, and then I can choose a prior whether it can be dependent, it can be independent. Okay, so then comes the dependence modeling part. In the dependence modeling part, so like this is called the aerial data because when you have some regions and for each region you have an observation. So this is called the aerial data in spatial statistics. And the idea is simple. So idea says that the spatial dependence of a region's response does not depend on the response of our regions given the response from its neighbors. Basically YT given YT minus 1, YT minus 2 and so on only depends on YT, only on YT minus 1. That's all. It does not depend on others. Okay. And the same idea I am assuming here for the spatial structure. Note that. So what these notations mean is that yi, suppose for a region I, conditioning on all other yi's depends on the normal distribution, but this mean structure is basically the average of the yi's only from its neighboring regions. Okay. So how a neighboring region is defined? So for example, like here say, so this is the called the, I think the lower West Bengal. So that shares boundary with, let's say, Jharkhand. Okay. It shares border with, let's say, Odisha. So then, so those corresponding Wij terms will be 1. Otherwise, they will be 0. Okay. So that's the structure. And then by Brooks lemma, so we get the full joint distribution of this vector y will be a Gaussian Markov random field, but it's much simpler case of a Gaussian Markov random field, basically a conditional autoregressive model. Okay. So, and as I said, so if the regions are neighbors, then Wij is 1, otherwise it is 0. Okay. So now, so that's the structure, but once again, note that this is defined in a normal state. I have to use it as a dependent structure only. So for that I need copula. So copula maybe many of you are familiar with. So let's not get into too much detail. So copula is basically a joint distribution where all the marginal distributions are uniform 0, 1. So basically suppose you have two random variables say y1 and y2. You just transform using f1 is the CDF of y1, f2 is the CDF of y2. So you just evaluate, all are continuous, uniformly continuous. So then u1 would be uniform 0, 1, u2 would be uniform 0, 1, but the dependent structure would be determined by the dependent structure between y1 and y2, right? Like here, the dependent structure was coming from the car model, but I want the margins to be uniform, okay? So I need to do some transformations accordingly. So we employ Gaussian copula, but the characterization would be through car model, okay? So we propose this Gaussian car copula model. Although I mean it's not like very how to say, like I did not see this much in the literature, although I mean it looks very relevant to me. So here it's simple. So let's say x tilde follows a zero mean car model with the same precision matrix as before, m minus rho w. So what we do, so let's say we take the covariance matrix and take the diagonals of them, scale the xi tildes. So then just to basically scaling, right? So then xi will be normal 0, 1, right? If earlier xi tilde were normal 0, say sigma square, I'm dividing by sigma. So then it is sigma. So then it becomes normal 0, 1, and then I'm transforming using the standard normal CDF. So they become ui, and then eventually the joint CDF of this u is determined is in this form. So this is the copula. So this is the Gaussian car copula. Note that, so we need to scale appropriately because this m minus rho w inverse, that matrix does not have the diagonal elements same. Okay. Okay. Once we do that, so then the full model specification is this. So then the YIT is suppose the monsoon rainfall for subdivision I for year T, and then we model the data layer using the canonical form of the gamma distribution that we did earlier. We transform using that CDF of that gamma distribution to uniform margins, and then those uniform margins are jointly modeled using a car copula structure. Okay, so the joint density obviously would be required whether we want a likelihood based or a Bayesian inference. So that turns out to be in this form. One good part is that, so note that this m minus rho w inverse, so this is a precision matrix is m minus rho w, right? Covariance matrix is this whole thing, but note that in the precision matrix, so this part is a sparse matrix, right? Because m is a sparse matrix, so it's a diagonal matrix, and w is 34 by 34 here, but lot of the elements are 0. For example, say West Bengal does not share a boundary with say Uttar Pradesh. So then the Wij would be 0 for that would be 0. Okay. Oh, now comes the spatially varying coefficients, because we need the coefficients are also varying across space because AI, DI, CI all are varying across space. So clearly we have observed some spatial patterns in those coefficients. Let's say we compare the models now. So let's say case 1, we take independent priors. Basically just say that I have AI, BI, so but they are positive only. So I am taking say AI star which is log of AI, BI star which is log of BI, and all these things as just IID parameters. Okay. Then I can take the car structure in the prior layer as well. So that is also possible. But note that, so here we have rho A, rho B, rho C. So these are called spatial autoregression coefficients. Okay. Now, sometimes, like note that, so we already have a car structure, sorry, copula structure, and the copula is only dependent on these things. So overall, I mean, the parsimony is also a matter here. I mean, we cannot just keep increasing the parameters like whatever way we want. So another model is we fix the parameters and we get the ICAR model, which is the intrinsic car model. Okay. Computation is purely Bayesian. So then we update all these vectors, say AI star, BI star, and C vector. So using like block metropolis strings. And the individual parameters, like the hyperparameters, they have their closed form of the full conditional posteriors. So we update them using the standard Gibbs sampling. And the missing data computation is also done using the multivariate normal vectors. And the NCNC change, so NCNC actually, I mean, maybe we don't need to run that much, but I think it's okay because it's pretty fast actually. But obviously for the scale of the problem, we just have 34 by 34, right? Which is not that big problem. And then we assess the convergence and mixing using the Gaussian statistic and effective sample size. Okay, then we do a simulation study, and so for different spatial correlation, autocorrelation parameters, we see, right? Because see, I mean, for example, if there is not at all any spatial dependence, then we don't need that copula structure at all, right? So we need to study like how the different levels of rho affect like the model performance. Okay, so we take different values of rho, 0, moderate, and very high. Okay, and under all these structures, so now we have two different possible models: independence or car in the data layer, and in the prior layer we have either independence, car, or high car. So basically 6 combinations we have. Okay, so with all these things we do a simulation study. So this is the full table, but like no need to like look into all the things, but the conclusions are here. So when basically this rho equal to 0, naturally this car ICAR or car independent ICAR more or less perform better compared to other, better in terms of this MAC posterior SD, average posterior SD, and the coverage probability. Okay, and when the rho is moderate, then the car ICAR performs superior, and when rho is 0.9, then car ICAR and car both generally perform better. Okay, so overall, because of the parsimony, we pick the car ICAR model and proceed with the inference. Sorry, cannot be negative. Oh no, rho cannot be negative. Yeah, rho is basically a spatial autocorrelation parameter which can take only positive values. So then we compare using AIC, DIC, and so this is Bayesian models. We cannot use AIC. So this is deviance information criteria and Watanabe-Akaike information criteria. So also, so what these are basically, so we simulated 100 different data sets. We fitted all possible models on all 100 data sets. So these are mostly done using parallel computing, and because it can take quite some time. Now, what we mainly note here that when the true correlation is 0, then the independent ICAR is performing better. When there is dependence, say moderate or high, we see that the car ICAR is more or less giving the smallest DLs. Okay? So we pick that model and go for the real data analysis. So in the real data analysis, again we note that in terms of DIC, WIC both, so all such 6 possible models. So we have, let's say, like we see that car ICAR performs again better compared to other models, and the average posterior SDs of these spatially varying coefficients and rho, so all of them suggest that car ICAR may be superior compared to other models. And so we pick that. For the NCNC diagnostics, we look into the effective sample size or Gaussian statistics, and they all are reasonable because, so here this Gaussian statistic, as long as this is between ±2, it is fine. We see that that is the case. And ESS, sometimes it is a little bit smaller, but in many cases it is bigger. So this is maybe reasonable. Okay. Sometimes, I mean, maybe it could be improved, but note that, so we are doing a block metropolis testing. So we are updating a 34-dimensional vector simultaneously. So it's not just one parameter updated at a time. Okay. So a block metropolis can be a bit not that great like single component updates. Okay. So this is the final outcomes. So we have what we wanted is basically the spatially varying A, B, C, and their corresponding posterior standard deviations. So all the things we have got. Now, main thing to note here that here the key parameter is basically C, because C determines whether like a climate change is happening or not, or like that is significant or not. So what we find here that only we find these three regions. Arunachal Pradesh is one region. I think Assam and Meghalaya is another region, and another region is this Mizoram, Manipur, and Tripura combined. I think so. That's how it is defined. And only for these three regions, note that C is significantly positive. Okay, but C is negatively linked to the increasing trend basically. So that means these are the three regions where the rainfall is kind of declining over, in the monsoon rainfall is kind of declining over the years. So there is some significant findings. And other things are also like the interpretation. So the spatial patterns are similar to exploratory analysis, which confirms that the model is more or less correct. Posterior mean of this row is 0.93, which indicates that the spatial correlation is strong. AI, BI, and CI, so all of them are like indicating the correct patterns, and the CI mainly showing a negative trend in rainfall and in the northeast part of India, which warrants further environmental assessment. Some remarks. So we developed a Bayesian latent Karpapula model for so this should be seasonal rainfall based on IMD subdivisions, and this incorporates the gamma regression with spatially varying coefficients, and we explored the Karaikar prior structures with spatially varying coefficients. MCMC is also scalable, and the real data analysis shows some significant negative trend in rainfall for three meteorological subdivisions. And at the same time, the model is for the environmental rainfall data in this case, but it can be implemented to some other problems as well. Okay, so I stop here and thank you for listening. So this is the QR code for the paper. Scan.
Thank you, sir. Now we can open the floor for questions.
So I have two questions. First, regarding the prior structure, you were so one. Can you show the slide? Case one, there were independent priors, and case two, the dependent prior, but the covariance matrix that is already calculated. So number of parameters, if I think of like that, we have the same number of new parameters. Case one and case two.
No, so in case two, we have this row A parameter extra, row B, row C. So those are extra hyperparameters.
But that is not a vector, one parameter per one vector.
No, so mu A is a single scalar, sigma A square is single, and rho is also a single parameter. And M and W matrix are coming from that card structure that I defined before.
Right, so those are calculated. So ultimately from case one to case two, you have three more parameters, or I'm missing some.
I mean hyperparameters you mean? Yes.
Okay. Okay.
Yeah.
And what is the case three? I could not.
So case 3 is basically the case 2, but if you take row A, row B, row C all as one.
Okay, so you just reduce the extra parameters but keep the covariance structure in a simplified manner. Okay, that was clarified already. Another thing is your finding was like the northeast part has a different pattern than the rest of the India.
Different in the sense that significantly the trend was the negative trend was significant in those three meteorological subdivisions.
So is it because can it be because of the fact that northeast part has almost no neighbors, right? So the neighbors, they are neighbors, but they are from different countries. So you might have put zero in your device.
I see your point. But one thing I feel that that's a bit unlikely. Because neighbor, what it can do, so the neighbor, the main purpose of neighbor is to reduce the uncertainty. It will not change the mean structure or the marginal structure of the parameters. So one possible thing is that the data quality that I am not going into, but if I consider the data quality is fine, then I feel that the dependent structure can try to reduce the uncertainty, but it will not change the marginal structure.
So something very similar. So I think from the plot, initially you show some plot. From the plot, it was not quite clear to me why you are restricting yourself to the car model. I think it's more appealing to me at least to use the SAR model, isn't it? I mean, in that case, you won't have that kind of problem which you are having possibly for the Northeast. Or maybe I'm missing something. So you saw some plot, right, initially?
Okay, I mean,
Some spatial plot, yeah.
here, let's say. Mhm.
Yeah, so why these plots actually motivate you to go for a CR? I don't see any solid reason for that, or maybe I'm missing something.
So car model is basically, I mean, if I consider into like the climate literature, I mean, both are there. I'm not
They are
saying
also there.
both are there, right? But I mean, usually car is, I would say, more common than SAR. That is one
I think
thing.
it depends on the structure.
On the structure, yes.
But this structure is not very clear from here how you supposed to go for a CR. That is not for a solid reason, isn't it?
So, I mean, the main reason was that, so from this plot, I think it was more clear from this plot. So here what happens is that, so if you look into, let's say Odisha, then Odisha has a very similar pattern with, let's say it's neighboring Andhra Pradesh, I guess, and this is Chhattisgarh. So then, so that's the pattern actually, it's kind of like a, so that means there are some spatial smoothness is required for the modeling purpose. It's not like arbitrarily varying across space. And that's the purpose, like to do a dependent structure model. That was.
I think it's also better to go for SAR and see which one is giving you some better fit. And
Oh.
also, you did not do any posterior predictive check, right?
That's a good point. Yeah. Posterior predictive check we did actually, but it's in the paper, so I thought of not this.
But otherwise,
Posterior predictive check was fine. Actually, we did it.
and also the CR model, and I'm not sure about the intrinsic CR model, but at least for CR model, they have some inbuilt INLA code.
Okay.
What is the computational cost? I mean, what is the computational time?
So computation.
But you are missingness also in your
Missingness,
all these
yes.
things are taking. I mean,
Right, but I mean, one thing is that, so suppose Simon ran very long, but let's say 200,000 is probably not required that much, but and maybe thinning by 20 is also too much, maybe, but I think he was mainly doing because the overall thing just takes maybe 1 or 2 hours. And I feel that that's happening mainly because there are no dependence across years. And also the dimension is just 34 along with that sparsity. But if we consider a bigger structure, then it would be.
typically for the complex spatial structure, MCMC, we know it's just a horrible thing.
Right.
Yeah, go for the inbuilt INLA code where they have all this very nicely developed. Also, people, I mean, questions about the reliability of this thing, but that's a different question.
No, so for INLA, I think only one issue is there. So INLA basically is a for latent Gaussian models are encoded. So latent Gaussian models are generally what happens is that in the data layer there are no dependence. In the latent layer there is a Gaussian structure, process structure, and there are hyperparameters. Here what is happening is that in the latent layer these parameters, there is a Gaussian process structure, basically multivariate normal, but at the data layer also we have dependence. Yeah. So I doubt whether that can be modeled using INLA.
Thank you for the engaging discussion.
Thank
Thank you, Dr. Harsha.
Thank you.
Excellent and thoughtful. With this, the academic session comes to an end, and the lunch has been arranged at rooms 423 and 424 ISRU Event. And after that, we will return to this venue at 3 p.m. for the afternoon session. Thank you.
ভালোর সঙ্গে আমার কখনো দেখা হয় না। অফিসিয়ালি দেখা হয়, আমরা চিনি। সৌরভের সঙ্গে আমার কথা হয়। হ্যাঁ, সেটা শুনতে পাই। আমি অনেকদিন ধরে আপনাদের সঙ্গে কনফারেন্সে মানে দূর থেকে দেখি। চিনি, ফরম্যাট সৌরভের সঙ্গে অনেকবারই কথা হয়েছে, তো তারপরে তো ওই আর কি আস্তে আস্তে আমাদেরও আমাদের এই প্রোগ্রাম আরো ইন্টারেস্টিং এগুলো কথা কেউ এখানে আছে, এখানে আসলে আপনার প্রবলেম হতে স্টুডেন্ট কাজ করে না এখন নিজের পেছনে সুচিতা অ্যাকচুয়ালি আমার ডিফেন্স কমিটিতে ছিল। কাজ করলে মানে লোক এত কম ওই ডিপার্টমেন্ট এখানে একটাই বেজিয়ানে কাজ করে এরকম ক্রিটিক্যাল রিভিশনে কাজ করে এরকম অ্যানিমেশন সমিতিতে থাকলে তো মুশকিল নাকি ও আচ্ছা আচ্ছা রিসার্চ করতে बहुत सारे इशू तो इम्पोर्टेंट है लेकिन लोगों को क्या ही कर सकते हैं वो
আচ্ছা এই সেখানে পিপিটি কি পেয়ে গেছে কি প্রেজেন্টেশন কিছু নেই তো?
প্রেজেন্টেশন এখন
মানে কালচারাল
হ্যাঁ আমাদের ওই প্রোগ্রামটা স্প্রেড করা হবে।
আচ্ছা
মানে স্ক্রিনের কি কাজ ছিল
স্ক্রিনের কিছু নেই ঠিক আছে তাহলে কি হয়ে যাবে
একটু
এটা বোধহয় ফাইনাল
স্ট্রিম বোধহয় হবে
স্ট্রিম হবে
স্ক্রিনের মতো ক্যামেরাটাকে ফুল স্ক্রিন করে দিতে হবে ক্যামেরাটাই ফুল স্ক্রিন
এটা ফুল প্রসেসিং করা আছে আগে ওই পিপিটি চলছিল বলে ওটা স্ক্যান করা ছিল কি করে
আমাদের এখানে একটা প্রোগ্রাম চলছে আজকে, যেটা সারাদিন চলার কথা, বলছি যে 5টা-10টা অবধি চলবে। তা যদি আমি আগে বেরোতে পারি, তাহলে কি আমরা 4:45 নাগাদ করার করতে পারি? কিন্তু এটা কি ব্যাপার নিয়ে বলুন। ঠিক আছে, তাহলে 4:45 ধরে রাখুন। আমার আর একটু দেরি হয়েও যেতে পারে, কিন্তু 4:45 আমার মনে হয় ঘুরতে হবে। ঠিক আছে।
বন্ধ করা হয়েছে মানে ওটা টিপটেও দিয়ে ওটা কালকের এই জিনিসপত্র এনে ওই নতুন গাইডকে বলা হয়েছে ওটা কংক্রিট ভাঙতে হবে, করে ও জয়েন্ট বের করতে হবে, পরে কালকের কাজ হবে। আপাতত জলটা বন্ধ করা হয়েছে, জল হচ্ছে পরে কালকে কাজ হবে। অফ করাটাই বেশি
আরে ইজি বলতে হয় তাতে গরম লাগবে
না
বাইরে থেকে এত ডিফারেন্স গেছে
আমার গরম লাগলে চালিয়ে ওই দুটো চলছে
না 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 সামনে একটা চালাও পেছন দিয়ে আরেকটা চালাও সামনে দিয়ে পুরো বন্ধ করে দিই
তাহলে ওটা বন্ধ করে
There's one song in the end.
One song in the end.
Yeah, yeah.
Not more than 1 hour.
Yeah, I think so. I mean, depends on
How many people are?
yeah. But we'll be asking people to like share their experiences.
Oh,
that
okay.
might take it.
ওপরে কথা হচ্ছে
all the retirees are and one song halfway even without the word they can and how long
that's dangerous for old people, you know.
not more than I'm not saying
সুবিত বিকেলের আগে আসে না কথা শুনে
বিকেল হতে আর কত বাজে?
না চারটে রেগুলারলি আসে আসে চারটে পর আসে ওর সত্যি সত্যি অনুষ্ঠান ওর সারা জীবন ধরেই কনস্ট্যান্ট আমাদের ফাংশন বসে তাও যা পড়লো বাকিটা একসময় তো মনে হচ্ছে মনে সেটাও করতে পারা সম্ভব অনেক রিকভার করেছে এখন তো একটু এই মতো প্রবলেম আছে কাজ থাকবে তারা অনেক কাজ করে
সেটাও তো তোমার করতে পারে
ওর রুটিনের মধ্যে থাকাকেও ভালোই আছে তাতে ভালোই একটা ক্লিকে বলতো আমার আগে এটা করবো বিশেষ তারাই বলছেন কি বলছে এটা বলতে হবে
শুনে কিন্তু এটা আমাদের সারপ্রাইজ করে দিয়েছিল আমরা তো একদম ভর্তি ছিলাম না ম্যানেজ করে দিয়েছিলাম উল্টো পাল্টা করে I was very pleasantly surprised. হতে চাই তো কিছু বলা যায় না আমরা ভাবি কখনো হতে চাই কিন্তু হয়ে একটা বিষয় প্যান্ডেমিকের সময় চাই প্যান্ডেমিকের সময় হলেও এনে দিয়েছিল
ঘরে আমার
কথা বলে কিন্তু লিখে দিতে হচ্ছে আপনি একটু কিছু বলুন আপনি গেলাম যে ওইটা করতাম কিন্তু ওনার আবার আমি ভাবতে ভাবতে তারপর যখন তাকে বলা হবে অনেকদিন তো হলো অনেক লিখেও কিছু হলো এবং তারপর আমি বলেছি কি একটা আমার তো সবাই বছর হলো সেখানে আমার মনে নেই কেউ সে অভিভাবক বেশি তোমার পরীক্ষা ছিল বাবু তাকে বুঝতেন দেখো তোমার তো এতদিন হলো আমার তো অনেক বছর হলো খারাপ লেগেছে কিচ্ছু সেখানে তো অস্বীকার করলেন তারপরে 2018 তাপস চন্দ্র হচ্ছে রিটার্ন করা জাস্ট মানে ওটা ফরওয়ার্ড ড্রেসিং করে হ্যাঁ ওই 8 ঘন্টা বসে দেখেছিল আমি ওষুধ দিয়েছি যদি আবার ব্লিডিং হয় শুধু লিকুইড জাতীয় কিছু লিকুইড খাবারই খেতে হবে এখন দুদিন কিছুই খাবি নিজেরই কথা বলতে হবে সবার সাথে কথা বলতে বলতে কমপ্লিট ছিল কখন কমপ্লিট করছি হ্যাঁ কামড়টা মাঝে মধ্যে জোরে লাগে দেখেছি আমার নাচ না করে প্রবলেম হচ্ছে লাঞ্চ করতে পারছো না শুধু গলা আর লিকুইড অনেক টক গুলোতে বলে দিলাম আমি পাচ্ছি না তুমি এত ভালো খাবারের আয়োজন করে না আমি গিয়ে ওরা কিছু ওরা বেশি কটায় বেরোবেন এটা হয়ে গেল আচ্ছা তাড়াতাড়ি এটা ম্যাক্সিমাম একদম এসছেন যাদেরকে করা হবে তাহলে আমরা স্টোরি বলা হবে তুমি শুরু করো অনেক আগে বলেছিল
Good afternoon, everyone. বিকেলের এই পর্বে উপস্থিত সকলকে জানাই আন্তরিক শুভেচ্ছা ও স্বাগত। আজকের দিনটি ইসরু পরিবারের জন্য সত্যি একটি বিশেষ দিন। গত 20 বছরে এই ইউনিট শুধু গবেষণা ও শিক্ষার ক্ষেত্রে নয়, মানুষের মধ্যে সম্পর্ক, সহযোগিতা এবং একসঙ্গে এগিয়ে চলার এক সুন্দর পরিসর গড়ে তুলেছে। এই দীর্ঘ পথ চলায় বহু শিক্ষক, কর্মী, গবেষক, ছাত্রছাত্রী এবং শুভানুধ্যায়ী বিভিন্ন সময় এই ইউনিটের সঙ্গে যুক্ত থেকেছেন। কেউ আজও এই পরিবারের অংশ হয়ে আমাদের সঙ্গে আছেন, আবার কেউ হয়তো অন্যত্র নিজেদের কর্মজীবনে প্রতিষ্ঠিত। আর কিছু প্রিয় মানুষ আছেন যারা আজ আমাদের মাঝে নেই, কিন্তু তাদের অবদান, তাদের স্মৃতি এবং তাদের উপস্থিতি ইসরোর প্রতিটি অধ্যায়ে চিরস্মরণীয় হয়ে থাকবে। আজকের এই অনুষ্ঠান তাই শুধু একটি বর্ষপূর্তি উদযাপন নয়, এটি সেই সকল মানুষকে সম্মান জানাবার একটি সুযোগ যাদের সম্মিলিত প্রচেষ্টা, শ্রম এবং আন্তরিক অংশগ্রহণে ইসরো আজকের অবস্থানে পৌঁছেছে। আজ আমরা ফিরে দেখব এই ইউনিটের পথ চলার নানা অধ্যায়, শুনব সেই যাত্রার গল্প, নানা স্মৃতি ও অভিজ্ঞতা। আমরা শুনব আমাদের শিক্ষকবৃন্দ, প্রাক্তন গবেষক, বর্তমান ও অবসরপ্রাপ্ত কর্মী এবং ইসরো পরিবারের অন্যান্য সদস্যদের থেকে তাদের অনুভূতি ও স্মৃতিচারণ। কারণ একটি প্রতিষ্ঠান কেবল তার ভবন, গবেষণাপত্র বা সাফল্যের মধ্যেই সীমাবদ্ধ নয়। একটি প্রতিষ্ঠানকে গড়ে তোলে তার মানুষজন, আর সেই মানুষগুলোর সম্মিলিত অবদানেই গড়ে উঠেছে আমাদের ইসরো পরিবার। আজ আমরা এখানে একত্রিত হয়েছি অতীতকে স্মৃতিচারণের সাথে সাথে ভবিষ্যতের পথ চলার জন্য নতুন প্রেরণা সঞ্চয় করার উদ্দেশ্যে। স্মৃতি, শ্রদ্ধা, কৃতজ্ঞতা এবং আনন্দের এই বিশেষ বিকেলটিকে আমরা সবাই মিলে উপভোগ করতে চলেছি। ধন্যবাদ।
আমরা এখন ইসরো পরিবারের সেই সদস্যদের স্মরণ করব যারা আজ আমাদের মধ্যে নেই। প্রফেসর তাপস কুমার চন্দ্র, প্রফেসর অরুণ অধিকারী, মিস্টার সুবর্ণ তপ্ন, প্রফেসর শঙ্কর ডিহিদার। তাদের স্মৃতির প্রতি গভীর শ্রদ্ধা জানিয়ে সকলকে 1 মিনিট নীরবতা পালনের জন্য অনুরোধ করছি।
ধন্যবাদ। এখন আমরা শুনবো ইসরোর গত 20 বছরের নানা অধ্যায়, শুনবো এর গড়ে ওঠার ইতিহাস এবং বিগত 2 দশকে নানা স্মৃতি ও অভিজ্ঞতার কথা। এই প্রসঙ্গে প্রথমে আমন্ত্রণ জানাচ্ছি আমি প্রফেসর অনন্তনাথ বসুকে।
So, shall I speak in Bengali or
Yes, sir.
is that accessible to all of you? No.
Yes, sir. But the researchers, I don't think.
No, but I think I should not speak in Bengali.
I couldn't.
Another history going on at the back? Okay, so good afternoon to all of you. So I am one of the few people who are still left here when ISRU was formed. It was not ISRU then, it was formed 20 years ago. Shorjit is also here. Shubir is not here. And that would be it, other than the some of the staff, Diptinbabu ছিলেন না যখন
The first
তৈরি হয়, the first section of that. Okay, so I came to this institute in 1995, the summer of 1995. I'm about to complete 31 years here. And before coming here, I was at the University of Texas at Austin. And at that place, I had seen that I was in the Department of Mathematics. And that university had, at the time I went there just before that, it had very good statisticians, including people like Carl Morris and David Hinckley. But it did not have a department of statistics. All the people were scattered in mathematics, business, and there was not a single coherent group. So when I came here, I had joined what was then called the computer science unit. So I still don't know why it was called computer science unit, but that was what it was called. And some people like Shiv Dakar, for example, thought that it was a more attractive name than being just a statistics unit. So I joined the computer science unit. And to be sure, there were many people there at the time who were not statisticians, not even close to being statisticians. Professors C.H. Shastri, for example, C.H. Shastri, Sunil Pal, Pavitra Pal Chaudhuri. There were a lot of people who were not statisticians. So I joined the computer science unit, and there was a stat math unit. If Shoshiman Srivastava would say, he would say math stat unit, whatever, but there was a stat math unit. But what were we doing in the computer science unit, I don't know. T. Krishnan had told me that whenever a new statistician applies, between stat math and computer science, whoever has a room available to house that person, he will be put there. So it was not that I wanted to be in the computer science unit. And it's not although that computer science unit was more applied and stat math was more theoretical, not even that. For I was placed in computer science, and my wife Srabushi was placed in the stat math unit. If theory versus application was the idea, then it would not have happened that way. So anyhow, so I joined the computer science unit, but starting from 1995, I felt it very often and talked to a lot of people that Indian Statistical Institute does not have a coherent statistics group. At that time, the statistics group in StatMath was very vibrant, of course. It still had Professor J.K. Ghosh, Shomesh Dasgupta, and there were the other people like T.J. Rao, S.B. Rao, B.B. Rao, Vikas Sinha, James Saha, all those people, including, of course, Arup Bose, Prabal Chaudhuri, Devaprishan Gupta, all of them were there, Devashishan Gupta when I joined. But no single coherent statistics group, pure statistics group. So for a lot of time, we have been asking for that. And there are some advantages in many ways. That this is perhaps not the right place to discuss that, but at one stage, this also became sort of political. I'm not going to discuss the point here, but I will try to say keeping that separate, but without suppressing the facts. So for a long time, it had been a demand of many of the statistics people in the institute that there should be a single department for statistics. Now, around 2000 or slightly before that, people realized that computer science unit was not working out, so it was renamed the Applied Statistics Unit. I think it was 1998, 1999, sometime like that. And at that time, Applied Statistics Unit was the only unit within the applied statistics division. So the situation became then that we had a theoretical statistics and mathematics division and the applied statistics division. Such a situation doesn't exist anywhere in the world. We have had departments of statistics, departments of biostatistics perhaps, but department of theoretical statistics, department of applied statistics, nobody else has thought about this. So we started asking for a division of statistics. Now, getting a division is not easy in this institute. Getting a division involves a lot of activity at the top, perhaps changing the memorandum and all that, but getting it is easier. That the director can create on his or her own. So, Paul became the director. We had asked him that there should be a separate department of statistics, and he agreed to create one applied statistics division. So we had a department of statistics within the applied statistics division where people from the ASU of at that time and the stat math unit of that time joined. I remember that myself, Professor Amita Paul, Professor Odikari, we joined this new unit from ASU. I don't recall this. Saurabh Bhattacharya also with that batch. I don't recall.
He was appointed
in the department. Originally Chakraborty, same thing. But from a bigger group came from StatMath, including Professor Jain Shah, Dorojit, Dumitra, Devkiro, Tapush Chandra, Rita Shahada. Shubir. So bigger group came from StatMath. And then Kumar Gihidar from possibly population sciences, he came and joined the unit, and at the time, that's how the unit was formed in 2006. But you have a unit applied statistics division, and there already exists an applied statistics unit. So what more do we get to the unit? So inspired genius thought about the name that Boots and no research unit. So we became Boots and no research unit. We had one organization architecture. Is going to have a lot of things. So let's say that the real monastery mission was short of Bhattacharya. But as time went on, when Professor Jim of our unit in 2006, he became head of the group. So he was head for 2 years, following which Professor Odikari was in for 2 years, and then I became the head in 2004. Meanwhile, in 2009, we got the IAS scheme and our population age increased to 65. And already superannuated at 62 were given the option to come back and work to 65. So GM came back. Because of came back. GM he had joined in 36 because he had not. In 2008, but Ask if you are comfortable here. I recall still have some photographs of Professor Jim Taha superannuating from Guru, Professor Amitabh with somebody felicitating him. Another thing that we should mention about sometimes after we were going on, sometimes the faculty went back to ISRU again. Among them were
What back? They were never part of this earlier. Sumitra, we hope you and
so anyhow, so the unit carried on, and at some point along the way, we decided to change our name, and we became interdisciplinary statistical research unit. And the applied statistics unit was renamed the statistical sciences unit. Applied statistics division was renamed the statistical sciences division. That perhaps reduced the but the main distinction still remains because the stat division still exists. It's a statistics, theoretical statistics and mathematics division. It's not just a mathematics division. So we have a statistics division and we have a theoretical statistics and mathematics division. So that's still an anomaly, but moving in the right direction. And in this, I think we have done well in terms of producing statistics graduates and doing recruitment at the moment. I am quite confident that we have the largest collection of statistics faculty in institute, and this is the only statistics department in the institute. We have at the moment 12 faculty, plus a professor. But soon, to me, myself, I'm sure it will be months to that, but hopefully we will have some success in recent in recruitment drives to fill in those positions. And I feel I'm very hopeful that our unit is looking up and we are having good people, and our research atmosphere is a vibrant one, and it's where statistics students at the moment will want to be. And we have produced many students during the last 20 years. Part of the last 20 years, because initially students were scarce in ISI. Even in 2005, there were very few research scholars, but now the number of research scholars is increased. Perhaps increased more than it should have, but there's no dearth of students right now. And I am very happy to see the state of the department. And when I leave in 1 year, I'm sure that the department will continue to progress and become strong. So, 3 cheers for ISRU.
থ্যাংক ইউ স্যার। এবার আমি আমন্ত্রণ জানাচ্ছি প্রফেসর সরজিৎ বোসকে আমাদের সঙ্গে কিছু কথা শেয়ার করে নেওয়ার জন্য।
Good afternoon, everyone. And just yesterday, I learned from Kiranmoy that I'm supposed to say something today. And even worse part was that I was supposed to speak before me. So then I knew that the problem will be that I probably would have much to say after what he says because we joined at the same time. We had very similar experiences. So Kiranmoy suggested that we talk between ourselves. Who is going to say what? And so far, we could not manage to do that before he started to speak. So I knew what was going to happen, that has happened. So
we will speak after you, sir.
So he's going to speak again after me. Anyway, so my story is kind of similar, but slightly different because he joined from ISRU and I joined from StatMath unit. So I joined in 1996, and my 30th anniversary in ISA is going to be next Friday, 19 June. And it is interesting that on 20th June, another person joined and shared the same room with me in StatMath, and he's the current director. So we'll be completing 30 years together. I didn't have the opportunity to remind him that. Maybe we should have some kind of celebration, he and me. So I didn't know the reason of me getting appointed in StatMath, because if I compare my work with him, definitely I'm much more applied than he was. And he was in applied statistics, and I never wanted to be in theoretical statistics. I'm not even sure what is theoretical statistics, because statistics subject itself is applied. And I had very difficult time explaining when I visited abroad what is theoretical statistics. So, and the kind of work I used to do, I don't think it should be called theoretical statistics. So that problem was there, and I heard that he said room allocation. I heard that being statistical institute, there's the probability distribution by which it is determined, though it was not sure whether there's a Bayesian part in that or not. But I ended up in StatMath, and what I saw gradually is that there is some kind of stress between the two subjects, in the sense that the number of statisticians were much less than number of mathematicians in office. Again, I don't want to be talking politically, but I also heard that before I came, Professor Shomesh Dasgupta put the initiative first to separate the department into two, and he felt that eventually that should be the way the institute should go. Because I never was a part of mathematics department in outside US. I was always in stat department, and it was kind of strange for me to see that there are very few statisticians and there are more mathematicians in the department. And I think I could collaborate more with people in applied statistics unit. So we didn't think that it is good for young researchers like us. So but at that time, when Professor Shomesh Dasgupta tried to do that, it was JKG. He simply told us later that I'm Jordan Dichiram. So he didn't agree. And when Jayanto Ghosh doesn't agree, nothing happens in SI. So that was that. And then after 2001, more problem became when Professor K.V. Sinha, who was the mathematician, he became the director. And somehow we felt that his idea of statistics is kind of deep-rooted in the 70s or 80s, and he doesn't care much about the modern directions. And there's more like growing, what should I say, kind of grievances in the StatMath department. So I think about 8 of our statisticians, we felt, would go to applied statistics unit, and we all 8 of us applied there. Director was not very enthusiastic because it looks kind of like a group of people suddenly moving, and applied statistics unit also didn't want to take all of us. So they offered that maybe 1 or 2 you can come and we can choose, but we said like we are facing a problem. So in fact, I was offered that you can come, but I said no, I'm not coming alone because all of us are having problems, so it has to be sorted out. So at that time, Professor Jayanto Ghosh said that I made a historic blunder. At that time, I should have agreed. And he became instrumental trying to have a statistics division, not just unit. So it was his idea that he realized, and his reason was that the first time when Professor Dasgupta suggested it, he decided because of mathematics. He said, I didn't think our mathematics was strong enough to survive without the statistics part. But at that point of time, like in 2002, 2003, he felt that mathematics is strong enough to be on their own, so it's not going to do any harm. Unfortunately, the director didn't agree, and then Professor Shankar Pal became the director. And actually, Professor Shankar Pal was indebted to Professor Jayanta Ghosh because when Jayanta Ghosh was the director, Professor Shankar Pal got the MIU. So naturally, when Jayanta Ghosh proposed that there should be a unit, he couldn't say no. So immediately after he joined, after he took the directorship in 2005, in probably August, 2006 March, I think probably this day, I'm not too sure. The notice came that there will be a new unit under the Atlas Statistics Division, and Professor Professor James Shah will be the head. So whoever wants to join can join the unit. So obviously, all of us who wanted to go to ASU, we joined, and in ASU, when there was a debate whether they should take all of us, again there was a difference of opinion, and Ayon, Amitadi, and Professor Ronald Odhikari felt that they should have allowed us to go there, and instead of that, that they're refusing to take their colleagues. So they felt that no, I think we should be together, and we are actually really grateful to them because the unit became not just a disgruntled faculty members from StatMath, should not be that way. And long way we came up to 2024, I think, when after a long, lot of efforts, and I'm a little proud to say that I was the professor in charge, and I really fought in the council to make this statistical science division happen. But definitely, many people helped me, and it was not like suddenly it happened. There are a lot of communications to the chairman, to the councils, that even the fourth review committee suggested that it should be this way. And so that's that. So now we have a very strong unit in a very strong division. And I don't think the StatMath division really suffered. They are also very strong. But still they want to hold on to the statistics part. But there are very few statisticians left. I don't know what will happen after Prabha retires, I think just before me. And I think Anil probably will be the only statistician left. And the other units of StatMath division, like in Delhi, they also felt the same way. So that's why the statisticians there have come out and formed statistical science unit. So, and that's part of statistical science division. So we have a restructuring, and I think it's for the better. That's what I feel personally. A few other details that I will probably missed. The name BIRU, like this Bayesian and Interdisciplinary Research Unit, many people omitted that end part. So they say Bayesian Interdisciplinary Research Unit. Then there's a problem because I'm not a Bayesian. So when I go to any other university or outside, they'll say, which unit are you in? BIRU. What is BIRU? Bayesian and Interdisciplinary Research Unit. I thought you were a statistician. Where is the statistics part? There is no statistics in BIRU. So I came back, and that was, I think, just early days, and I told my colleagues that probably his name should be changed. And I think Professor Ronald Odhikari suggested that it should be ISRU, but somebody said it sounds like Oshru. And somebody said it's very close to ISRO. There could be confusion. So that was that, and somebody said, from Shode is very powerful. So we should have to stick to that way. So there are a lot of debate about what the name should be. But finally, our Bayesian people like Shumitro or Ijit, they left, and Shorav became only Bayesian. And we felt that this Bayesian does not justify. When one Bayesian in the department, then it should be Bayesian, pattern recognition, robust intelligence, because we all are working in different areas. So there is not a strong Bayesian group. So we wanted to do that. Then again, what should be the name? So I think we agreed that there should be statistics first of all, and interdisciplinary studies is a very, modern area, emerging area. And it's true that many of us had collaborations with other disciplines. So in fact, at that time, I think Yuvalda was the director. He wanted a justification on how interdisciplinary you are. So I'm proud to say that we gave a long list of at least 50 publications of our faculty members, which are not in pure statistics. So he was surprised, said, wow, I didn't know that. So that's good. But I think, the kind of composition that we have in the unit right now is definitely justifies the name. And it is becoming more interdisciplinary, and that's the way to go. We all know that. So I think we are kind of, at least without knowing at that time, visionary that the name actually is very modern nowadays, and everybody is moving into that direction in outside world. So statistics is changing. So I'm very happy for whatever has happened in these 20 years. I met a lot of nice colleagues, staffs, and of course the research scholars. I think they are the product of this unit, so to say, and they are doing fine. Some of them are here, and I wish everybody well. And I leave after, I think, 1.5 years after one leave, so that's not too long in future. But I think whatever time I have here, I'll be always here to guide the young people, and I take interest in everybody's career, whatever way I can. And I think there's a great future ahead for the unit. So best wishes to ISRU in next decades. Thank you.
Thank you, sir, for that beautiful anecdote. Moving on, কোন প্রতিষ্ঠানের ইতিহাস শুধু তার গবেষণার সাফল্য বা অর্জনের মধ্যেই সীমাবদ্ধ থাকে না। সেই ইতিহাসের সঙ্গে জড়িয়ে থাকেন বহু মানুষ, যাদের নীরব পরিশ্রম, আন্তরিক সহযোগিতা এবং প্রতিদিনের অবদান একটি প্রতিষ্ঠানকে ধীরে ধীরে করে তোলে। ISRUর গত 20 বছরের স্মৃতির সঙ্গে এমনই অনেক মানুষের নাম জড়িয়ে আছে। আমাদের অবসরপ্রাপ্ত সহকর্মীরা এই ইউনিটের বিভিন্ন সময়ের সাক্ষী। তাদের কর্মজীবনের অসংখ্য স্মৃতি, অভিজ্ঞতা এবং অবদান ISRUর সঙ্গে ওতপ্রোতভাবে জড়িয়ে আছে। আজকের এই বিশেষ দিনে তাদের প্রতি আমরা শ্রদ্ধা, কৃতজ্ঞতা এবং ভালোবাসা জানাতে পেরে আমরা সত্যি আনন্দিত। এবার আমরা তাদের সম্মান জানানোর পর্বে এগিয়ে চলি। Our next felicitation is for Shagotadi. I request Tanmoyda to kindly felicitate her.
মানুষকে ফেলিসিটেট করতে পেরে, এবং তার থেকেও বড় কথা, আমার এত বছরের কর্মজীবনে দিস ইজ দ্য ফার্স্ট টাইম আমি দেখলাম যে রিটেল পার্সনদের এরকম ভাবে ডেকে নিয়ে এসে তাদেরকে ফেলিসিটেট করা হচ্ছে, মানে সত্যি অ্যাপ্রিসিয়েটিং।
কথা বলবো।
মাইক্রোফোনটা দাও। স্বাগতাদির সাথে কয়েন টকিং এর সম্পর্ক আছে।
So I want to tell that story. Shagotadi got appointed when Bimala was the director, right? So Shagotadi and some other staff at one point had got or were offered appointment because they had there was a lawsuit which they had filed in Calcutta High Court, right? But somehow she and somebody else could not get appointed at that time. So when Bimala offered them, that was in 2000. Okay, but Shagotadi and somebody else, there were two candidates. Bimala agreed to put one of them in AC and one of them in at the time. Not the other person. So we actually did a quantum experiment in the director's office and decided that Shardari will come to ISRU and the other gentleman, I don't want to your names here, you go to ISRU and that was what happened.
তার মানে কমেন্ট টক্সিংটা কাজ করে কমেন্ট টক্স করে কিছু করা যায় আরে ওটা স্কুলের করে ঠিক আছে তোরে বল
Our next felicitation is for Krishnoda. I request Pranamita to kindly come forward.
এটা এটা তুমি আমি এগিয়ে দিচ্ছি তুই এগিয়ে দিতে বড় দিচ্ছিল সমান হ্যাঁ বল কিছু বলবেন নাকি কিছু বলুন
এটা খুশি বলুন সবার মধ্যে দিয়ে দিচ্ছে ওইদিকে বোধ
ভাগাভাগি হলে একটু আর দিন মিলে আমরা তোমার বোধহয় 2006 এখানে চলে এলাম তখন তো বিল্ডিংটা কমপ্লিট মানে কাজ হচ্ছিল করতে 2017-তে রিটায়ার করলাম তবে জুড়িতে আসার পর মনটা খারাপ হয়ে গেছিল প্রথমে যে একটা জায়গায় ছিলাম এত বছর তারপরে এক জায়গায় মনটা খারাপ হয়ে গেছিল সত্যি খারাপ হয়েছিলাম তারপর আস্তে আস্তে বছর খানেকের মধ্যে তখন এই জায়গাটাই ভালো লাগলো তখন আর ওখানে ভালো লাগতো ওখানে তখন যেতাম না এখানেই পড়ে থাকতাম একটা থেকে টিফিন হতো আমি অফিস ঘরেই বসে থাকতাম বাইরে খুব কম বসতাম এইভাবে কাটিয়ে দিলাম এত বছর এমনি সবাই ভালো ছিলেন ফ্যাকাল্টিরা অফিস স্টাফে সবাই ভালো ছিলেন কেউ কে প্রফেসর ইনচার্জ কে স্টাফ কেউ জানতো না এখানে সবাই এক হয়ে থাকতাম তাই তো আমরা
একদম
Our next felicitation is for Dipenduda. I request Shomarji to come forward to felicitate.
একটা পরে দিল
আপনি কিছু বলুন মাইকটা দাও
ইসরুর আগে
মুখের কাছে
ইসরুর আগে এই ইউনিটের নাম ছিল ভিরু। ভিরুতে আমি এবং আমার কলিগ বিষ্ণু ব্যানার্জি আর আমাদের হেড ছিলেন জিএম শাহ, এছাড়া ফ্যাকাল্টিরা সব ছিলেন। তো প্রথম থেকেই আমার খুবই ভালো লাগছিল, এবং শুধু এখানেই নয়, যেখানে যেখানে আমি কাজ করেছি এই আইএসএ, সব জায়গাতেই সবার কাছ থেকে রেসপেক্ট পেয়েছি। এটা খুব বড় কথা, যেটা অন্য কোথাও গেলে হয়তো আমি পেতাম না। আমি আইএসএ তে আসার আগে অনেক ভালো জায়গায় সব কাজের অফার পেয়েছি, কিন্তু যেহেতু এটা আমার নিজের চেষ্টায়, নিজের পরীক্ষা টরীক্ষা দিয়ে যেভাবে এসেছি আমি, সেই জন্য আমার একটা স্যাটিসফ্যাকশন ছিল যে এরকম একটা জায়গায় অন্য জায়গা থেকে কম মাইনে হলেও এখানে অনেক সুন্দর জায়গা, এবং আমি এখানে এসে সত্যি লাভবানই হয়েছি। সবার মানে ভালোবাসা পেয়েছি, সম্মান পেয়েছি, এবং যতদিন আমি এখানে চাকরি করেছি সবার কাছ থেকে আমি সেইটুকু পেয়েছি। এটি আমার জীবনে একটা বিরাট বিরাট মানে লাভ বলতে পারি আমি। তবে এখানে হয়তো কোনো কোনো সময় কারোর সঙ্গে আমার হয়তো মনোমালিন্য হয়েছে, কিন্তু সাময়িক, পরক্ষণই আমরা ভুলে গেছি সেই জিনিস, আমরা ভুলে গেছি, এবং আবার সে একই পরিবারের সদস্য হয়ে আমরা আমাদের চলতে হয়েছে। ফলে আইএসআই সেই ঐতিহ্য যেন আগামী দিনেও বজায় থাকে, আমি সেইটুকু আশা করে সবার কাছ থেকে বিদায় নিচ্ছি।
শান্তি দিকে সম্বর্ধনা জানানোর জন্য আমি সর্বজিৎকে ডেকে নেবো। শান্তি।
আপনি কিছু বলেননি, আপনার গানটা করতেন।
তাহলে নিচেই দাঁড়া, নিচেই দাঁড়া, নিচেই দাঁড়া। আপনি দিকে একটু বলুন।
ব্যাগটার মধ্যে সবগুলো ঢুকি দাও। হ্যাঁ, আলাদা করলে প্লাস্টিকটা দেখি।
নেক্সট আমি নন্দদাকে রেখে নেবো, স্বর্ণদীপ যদি উঠে আসে।
যদিও বলার জন্য আমাকে কেউ রিকোয়েস্ট করেনি, আমি জয়েন করেছি 1989 আমি প্রথম জয়েন করি ইকোনমিক রিসার্চ ইউনিট। তারপর দীর্ঘ সাইকোলজি সাইকোমেট্রি যেটা ছিল আর কি বলুন, তারপর সাইকোলজি রিসার্চ করেছি। তারপর করেছি আমি ধরুন ডেমোগ্রাফি, সোশিওলজি, তারপরে ডিপার্টমেন্ট হলো আমার হিরো। এখানে এসে আমি খুব কম সময় কাটিয়েছি, হয়তো খুব বেশি হলে 2 বছর কাটিয়েছি, কিন্তু ভীষণ আনন্দের দিক কাটিয়েছি, খুব আনন্দ করে কেটেছে। কখনোই মনে হয়নি এবং অফিস কামাই করতে ইচ্ছে করতো, অকারণে ছুটি দিতে ইচ্ছা করতো প্রত্যেকে এতটাই সহযোগিতা করতেন যে কোনো সময় অনেক কিছু বুঝতাম না চট করে দ্বিধায় ঢুকে যেতাম ওই তখন আমার যখন আমি এসেছি তখন অয়ন নিজে হেড ছিলেন এই ডিপার্টমেন্টে কত কিছু বুঝতাম না কত কিছু জানতাম না একবার সরাসরি দরজা না জিজ্ঞেস করে সোজা ঢুকে এটা কিভাবে সলভ করবো এটা কিভাবে করবো এটা কি লিখতে হবে প্রতিটা বিষয় যেভাবে সহযোগিতা পেয়েছি মনে রাখার মতো তাই আমার আমার মনে হয় সামান্য একজন কর্মী এখানে এসে কাজ করতে পেরে নিজেকে বড় বোধ করি এবং এর জন্য অসংখ্য অসংখ্য ধন্যবাদ আপনাদের প্রত্যেককে যাদের থেকে এই সহযোগিতা আমি পেয়েছি Our next felicitation is for Devobrotola. I request Temjelinga to kindly felicitate him.
একটু বলুন
নমস্কার সবাইকে
মাইকটা অন করো
নমস্কার সবাইকে আন্তরিক নমস্কার এবং শ্রদ্ধা জানিয়ে কিছু বক্তব্য রাখার জন্য বলছি সেই জন্য একটু বক্তব্য রাখার চেষ্টা করছি আমি ইনস্টিটিউটে প্রথম যখন জয়েন করি সেটা 1991 সালে আমি একটা শিক্ষা প্রতিষ্ঠান থেকে আমার একটা অন্য শিক্ষা প্রতিষ্ঠানে জয়েন করেছি সেটা ছিল কেন্দ্রীয় বিদ্যালয় এটা হচ্ছে ইউনিভার্সিটি যাই হোক সেই প্রথম দিনের অভিজ্ঞতা ছিল আমাদের শ্রদ্ধেয় প্রফেসর বিজয় দত্ত মজুমদারের ইউনিট ইলেকট্রনিক্স এন্ড কমিউনিকেশন সায়েন্সেস সেখানে দীর্ঘ 800 বছর আমি মানে সার্ভিস করেছি তার পরবর্তীতে আমি একা সিএমইউ তে জয়েন করি সিএমইউ তে জয়েন করার পর আমার যখন প্রমোশন হয় তখন আমার একসাথে দুটো ইউনিটকে দেওয়া হয় একটা হচ্ছে আইজ্যাক যেখানে প্রফেসর অয়ন ছিলেন ওখানকার মানে মেম্বার সেক্রেটারি এবং ইসরু ইসরু আমাকে দায়িত্ব দেওয়া ইসরুতে তখন হেড ছিলেন রিতান তা খুব অল্প সময়ের মধ্যে আমি এখানে কাজ করেছি কিন্তু সেই ভালোবাসাটা পেয়েছি কিন্তু অনেক সেটা মনে হয় সংখ্যা দিয়ে বা মুখে বলে সেটাকে প্রকাশ করা যাবে না ভাবাবেগটা অনেক বড় অনেক বেশি বলার স্কোপ হয়তো এখানে নেই যা ইচ্ছে ছিল অনেক কিছু বলার কিন্তু অনেক অনেক বেশি ভালোবাসা পেয়েছি যেটা খুব অল্প দিনের মধ্যে যার একটা প্রধান উদাহরণ হচ্ছে আমি এতদিন এতগুলো ইউনিটে কাজ করেছি কিন্তু সে সমস্ত ইউনিটের অনেক জায়গাতেই অনেক রকম ফেলিসিটেশন হয়েছে আফটার মাই রিটায়ারমেন্ট কিন্তু আমরা ইসরুতে যে সামান্য দিন কাজ করেছি কিন্তু তারা মনে রেখে যে আমাকে এই দিনটায় ডেকেছে তাদের এই প্রতিষ্ঠা বার্ষিকীতে যে ডেকেছে এটা আমার কাছে খুব গর্বের বিষয় খুব আনন্দের বিষয় এরকম অনেক হয়তো উদাহরণ বলা যাবে কিন্তু সেই সময় বা পরিসর এখানে নয় কারণ মানুষ এখন অন্যান্য বিভিন্ন কাজে ব্যস্ত থাকে পরিসরটা বিস্তৃত করতে চাই না যাই হোক এদের প্রত্যেকটা ফ্যাকাল্টির সাথে বলুন স্টুডেন্ট স্কলার রিসার্চ স্কলার প্রত্যেকের সাথে এত সৌহার্দ্যপূর্ণ রিলেশন তৈরি হয়েছে যেমন জয়েন করে যখন আমি শেষের দিকে জয়েন করেছিল সরজিৎ দা ছিলেন সরজিৎ দার সাথে প্রত্যেকের সাথে আমার আগেও পরিচয় ছিল কিন্তু এখানে আসার পর আরো বেশি পরিচয় পলিসি ইনচার্জ ছিলেন ওদের সরজিৎ দা যখন জয়েন করেছি তখন না পলিসি ইনচার্জ ছিলেন আপনি না আমি যখন জয়েন করেছিলাম আপনি বোধহয় পলিসি ইনচার্জ হ্যাঁ আর এর তখন হেড ছিলেন রীতাদি হেড ছিলেন রীতাদি যা হেড কমপ্লিটেশন করলো তারপরে বোধহয় খুব সম্ভবত আপনি বোধহয় ইনচার্জ হয়েছিলেন অমিতা বেরিয়েছেন তারপর আপনার সময় কিছুদিন ছিলেন আপনি আমার কন্ট্রোলিং অফিসার কিছুদিন ছিলেন হ্যাঁ অল্প কিছুদিনের জন্য এমনি আপনি ওই লিভ এরিয়াতে কিছু ছিলেন বোধ হয় রীতাদি ভাই নাচ ডেপুটেশন কি বলে যে প্রত্যেকের অসীম ভালোবাসা সহানুভূতি এবং সহযোগিতা পেয়েছি সেটা যেমন ফ্যাকাল্টি লেভেল থেকে পেয়েছি স্টুডেন্ট লেভেল থেকে যেমন অভিক আমার খুব মানে একদম প্রতিবেশী বলা যায় অভিক আছে বলে এখানে নাকি অভিক আছে অভিকের সাথে আমার মানে প্রতিবেশী হিসেবে সম্পর্ক হচ্ছে, এইখানে সম্পর্কের জন্য আরো প্রগাঢ় হয়েছে। যাক, এরা প্রত্যেকে আমাকে খুব সম্মান দিয়েছে এবং তার একটা প্রকৃষ্ট উদাহরণ আমি আরো বলছি যে এই দিনে আমাকে ডেকে আমাকে যেন আরো বেশি উজ্জীবিত, এই দিনটা আমার কাছে খুব গর্বের বিষয় হয়ে গেছে। যাই, সবাইকে নমস্কার জানিয়ে আন্তরিক নমস্কার জানাই, আন্তরিক কি বলবো, শুভাকাঙ্ক্ষী, প্রত্যেকেই আমার শুভাকাঙ্ক্ষী। স্টুডেন্টদের আরো বলবো যে তোমরা আরো বেশি করে নিজের কাজে, রিসার্চের কাজে এই ইউনিটকে আরো বেশি উন্নীত করো, আরো উপরের দিকে নিয়ে যাও। এই আবেদনটুকু তোমাদের কাছে রেখে আমি আমার বক্তব্য শেষ করি।
ধন্যবাদ সবাইকে। গত 20 বছরে ইস্যুর সঙ্গে জড়িয়ে থাকা আপনাদের প্রত্যেককেই এই পরিবারের গল্পের এক একটি গুরুত্বপূর্ণ অংশ। আজকের এই বিশেষ দিনে আপনাদের মধ্যে কেউ যদি কোনো স্মৃতি, অভিজ্ঞতা, অনুভূতি বা কিছু কথা আমাদের সঙ্গে ভাগ করে নিতে চান, তাহলে আমরা খুব আনন্দিত হব।
আমি একটু বলতে আচ্ছা, সবাইকে ধন্যবাদ। আমি একটু বলতে চাই, যেটা আমি এই ডিপার্টমেন্টের ফ্যাকাল্টি নই, আমি রিটায়ার করেছি ফিজিক্স অ্যান্ড অ্যাপ্লাইড ম্যাথমেটিক্স ইউনিট থেকে। কিন্তু আমাদের ওখানে আমি তখনও রিসার্চ করি, অ্যাক্টিভ রিসার্চ বলে আমাকে ডিরেক্টর বলেছিলেন। কিন্তু আমাদের ডিপার্টমেন্টে কিছু জায়গার সমস্যা হয়। ওনারা বলেন যে ইউনিভার্সিটি খুব চালুও ছিল না, অনারি রেজিস্ট্রিং পজিশনে এখানে জায়গা হবে না। তখন আমি আমার ছাত্র অভিকের সঙ্গে একটা জয়েন্ট প্রজেক্ট আছে আমার, এখন যেটাকে এনআরএফ বলে, সার্ভে। তো আমি সমহিতটাই বলতাম, বিশেষটা থাকলে আমাকে নিয়ে সমহিতটা ডেকে বললো, বলছি ডিপার্টমেন্টটা অসুবিধা, আপনি তো অভিকের সঙ্গে জয়েন্ট প্রজেক্টে আছেন, আপনি একটু ইসরুতে কথা বলে দেখুন, না হলে পরে আমি এমআইউ তে কথা বলবো, আমি এখানে কোথাও জায়গার ব্যবস্থা হবে, আপনি আসবেন। তো আমি অভিকের সঙ্গে কথা বললাম, অভিক তো সঙ্গে সঙ্গে বললো হ্যাঁ কোনো অসুবিধা নেই ম্যাডাম। তারপর আমি অমিতার সঙ্গে কথা বললাম, অমিতা বললো হ্যাঁ তুমি একটা চিঠি লেখো, আমাদের জায়গার অতটা সমস্যা নেই, তুমি যখন কাজ করো তোমার। আর তখন আমার প্রজেক্টটা আছে আর কি, মানে সেটা আমি 22শে নভেম্বর রিটায়ার করি, ওটা 23শে জুন অব্দি ছিল আর কি। তো আমি মিঠে ধরছি, যাই হোক আমি অ্যাপ্লাই করাতে, মানে অমিতা ওকে কথা বলাতে অমিতা বললো হ্যাঁ আমি তো রাজি আছি, কিন্তু আমি একা বললে তো হবে না, তুমি একটা মেল করো, আমি সবাইকে একটু ডিপার্টমেন্টে পাঠাই, তোমার সিভিটিভি দিয়ে তারপর দেওয়া যাবে। তারপরে ও এগ্রি করলো। ডিরেক্টর তো আগেই বলেছিলেন, ডিরেক্টরের তো অসুবিধা ছিল না, ডিপার্টমেন্টের সবাই এগ্রি করাতে ওটা আমি পেলাম। মানে আমি ভেরি থ্যাঙ্কফুল, আমি বলবো। আমি তারপরেও মোটামুটি রিসার্চটা এখনো চালিয়ে যাচ্ছি। এরপরে অয়ন এসেছে, কিরণমা এসেছে, সকলেই আমাকে মানে ওটা এক্সটেন্ড করেছে, 6 মাস করে আমি এক্সটেনশন পাচ্ছি, এবং ওরা কেউ কখনো এক মুহূর্তের জন্য আমাকে এখানে বুঝতে দেয়নি যে আমি এত পরে এসেছি এখানে। অফিসও ভীষণ ভালো, ফ্যাকাল্টিরা প্রত্যেকের সঙ্গে, অনেকের সঙ্গে পার্সোনাল আলাপ আছে যারা পরেও এসেছে, মানে করিডোরে দেখা হয়নি, হাসি মুখে কথা বলা। খুব রিসেন্টলি সরজিৎ আমাকে একটু ডেকে বললো একটা প্রজেক্টে আমরা হয়তো একসঙ্গে কাজ করব। তো মানে আমি এই ইস্যুর কথা, আমি পামুতে বহুদিন, মানে আমি 95 থেকে ফ্যাকাল্টি, 2022-এ রিটায়ার করেছি। তার আগে আমি আমাদের এখানে যেটা সবাই বললেন ইলেকট্রনিক্স ইউনিট বলে একটা ইলেকট্রনিক্স ইউনিট ছিল। ওই এক্ষুনি আমি আজকে দেবাশিস কুণ্ডুকে বলছিলাম, আমার বাবার সঙ্গে আমার আলাপ ছিল আমি যখন স্টুডেন্ট, তখন ওই রামেশ্বর কুণ্ডু উনি আসতেন আর কি আমাদের ডিপার্টমেন্টে। মানে তখন আমি ওনার কথা শুনেছিলাম, পরে শুনেছিলাম উনি চাকরি পেয়েছেন আইআইটি ফ্যাকাল্টিতে। তবে আজকে ওনাকে জিজ্ঞেস করলাম আপনার কি চন্দননগরের বাড়ি, মানে কুণ্ডুদার কাছে চন্দননগরের বাড়ি, এটা আমি জানতাম। উনি বলেছিলেন আমার ছেলে এখান থেকে বিস্তার পাস করেছে, সে বাইরে গেছে, খুশি হয়ে বাবা যেরকম বলে আর কি। তো সেটা শুনলাম যে হ্যাঁ উনি উনি সেই দেবাশিস আর কি। তো আমি ইসরোকে অসম্ভব ধন্যবাদ, সবাইকে, স্টুডেন্টদের সবাইকে বলবো, মানে ভীষণ ভালো একটা ডিপার্টমেন্ট। আমি অনেককে হয়তো আলাদা করে চিনতাম, যেহেতু এতদিন এখানে আছি, আইএসআর প্রচুর লোককে চিনি। আর আরেকটা হচ্ছে আমাদের অনেক আগে একটা এন্ট্রি কমিটি হতো, সেই কমিটিতে আমি অনেকবার কাজ করেছি, যার ফলে অনেক ডিপার্টমেন্টের লোকেরা সেই কমিটিতে কাজ করতো, কিন্তু পরিচয়ের ইয়েটা অনেক বড় ছিল। আর মোটামুটি একটা কথা বলা মানুষ আর কি, চুপচাপ থাকি না, কাজে আমার পরিচিতির সংখ্যাটা প্রচুর। তো এখানে এটা মানে আমি ভীষণ মানে থ্যাঙ্কফুল সবাইকে আর কি, গ্রেটফুল, থ্যাঙ্কফুল যা বলবো। আমি এখনো রিসার্চে চালিয়ে যাচ্ছি,
অভিক আমার স্টুডেন্ট ছিল, বিস্তার পড়ার সময় থেকে আমার সঙ্গে ওর প্রজেক্ট, এখনো আমরা একসঙ্গে কাজ করছি, এখনো একটা কাজ মানে রেগুলারই কাজগুলো বেরোয়। তো অনেক ধন্যবাদ। আমি নিজে একটু বলতে চাইলাম ইসরোর প্রশংসাটা আমি এখন বোধহয় বাইরে কোন এমন একটা জায়গা নিয়ে আমার সঙ্গে যাদের পড়াশোনার কথা হয় আমি এই কথাটা না বলি, যে একটা অন্য ডিপার্টমেন্ট থেকে গিয়ে যে সম্মান, যে ভালোবাসা, অফিস স্টাফদের বেশি করে, ফ্যাকাল্টিরা তো ঠিক আছে জানেন তারা দিচ্ছেন, কিন্তু তাদের সঙ্গেও সবার সঙ্গে ভীষণ ভালো সম্পর্ক, খুব ভালো ডিপার্টমেন্ট, খুব ভালো হোক এই ডিপার্টমেন্টই আমি চাই সবার কাছে, এই বলে আমি শেষ করলাম।
হ্যাঁ, আপনার আমি স্বাগত দিকে একটা গান করার জন্য ডাকবো স্টেজে।
একটা বেশি তো হচ্ছে বেশি হতে পারে হারমোনিয়ামে জোগাড় করা গেল না, কিন্তু খালি গলাটাই শুনতে চাই, আগে বললে জবাব করে দিতাম।
নইলে কে আর পারবো তোমার চরণ ছুঁতে, দয়া তব দয়া তব দয়া দিয়ে হবে গো জীবন ধুতে। তোমায় দিতে পূজার ডালি বেরিয়ে পড়ে সকল কালে, তোমায় দিতে পূজার ডালি বেরিয়ে পড়ে সকল কালে, দিও না গো দিও না দয়া তব দয়া তব দয়া দিয়ে হবে গো মোর জীবন ধুতে। এতদিন তো ছিল না মোর কোনো ব্যথা, সর্ব অঙ্গে মাখা ছিল মলিনতা। এতদিন তো ছিল না মোর কোনো ব্যথা, স্বর্গ অঙ্গে মাখা ছিল মলিনতা। আজ ওই শুভ্র কোলের তারে ব্যাকুল আজ ওই শুভ্র হবে গো জীবন ধুতে, নইলে কি চরণ ছুঁতে, দয়া তব দয়া তব দয়া দিয়ে হবে গো মোর জীবন ধুতে।
ধন্যবাদ স্বাগতা দি। আচ্ছা, আমি অন সাইডে রিকোয়েস্ট করব উনি যদি আমাদেরকে একটা গান গেয়ে শোনান।
দেবাশিস কি বলবেন, বিশেষ করে গান গাইয়ে গান শুনিয়ে ছবি ছাড়বি?
আগোটা দিকে ছাড়া আমাদের বিষ্ণু ফ্যামিলির মেম্বাররা কিন্তু গান গেয়ে দিতে পারেনি এটাও একটা বোঝায় আমাদের তারা মানবতা কিভাবে গর্ব করার জায়গা। আজকের অনুষ্ঠানটা প্রায় শেষের দিকে যে কথা বলার জন্য আমি এলাম সেটা হচ্ছে আমরাও যখন জয়েন করি তখন অয়নদা সহযোগিতা অমিতাদি ইত্যাদি এদের কাছে আসা রামকৃষ্ণ মিশনের ছাত্র বরাবর আমি সালকে কখনো খুব একটা পছন্দ করতাম না ছাত্র জীবনে এখানে আসার কোনো ইচ্ছেও ছিল না করেছিলাম কিন্তু উনি আমাকে ঢুকিয়েছিলেন কিন্তু বুঝেছিলাম যে এটা একটা রামকৃষ্ণ মিশনের মতো জায়গা। এখানকার প্রত্যেকটি সিনিয়র কলিগ যারা ছিলেন তখন আমাদের এখনো আছেন সরজিৎ দা অরুণদা এরা আমাদের ছিলেন স্বাগতের অমিতাদি প্রত্যেকে। তো আস্তে আস্তে ওনারা সবাই রিটায়ার করছেন এবং সেই জায়গাতে আমাদেরকে উঠতে হবে আমরা জানি উঠতে পারবো কিনা সেই জায়গাতে পৌঁছানোর চেষ্টা করি হয়তো হয় না ভেতর থেকে আসে। আমি শুনেছি কৃষ্ণবাবু একবার বলেছিলেন যে অরন্দা যখন এখানে জয়েন করেন কোনো একটা সময় এসিউতে তো প্রচন্ড বৃষ্টিতে বোধহয়
জানলা দিয়ে জল টল ঢুকে গেছে ওনার ঘরে। উনি পরের দিন সকালবেলা এসে নিজেই ঝাড়ু দিয়ে জলটা পরিষ্কার করছেন, কিন্তু কারণ যারা করার কথা সে অন্য কাজ করছে, তো তাকে না বলে নিজেই কিন্তু ঝাড়ু টাড়ু দিয়ে নিজে পরিষ্কার করছেন। এইরকম কালচার দেখেছি শুনেছি এখানে, যেটা খুব ভালো লেগেছে আমাদের। এবং এখন বলছি যে ইস্যুটা আমাদের বোধহয় অন্য জায়গার থেকে, অন্য ইউনিট থেকে অনেক আলাদা, সেটা অনেকেই বললেন। সেই রকম জায়গায় দাঁড়িয়ে আমাদের সামনে এখন অনেক পথ চলা, মাত্র 20 বছর হয়েছে, আর অনেক দূর যেতে হবে যখন তাকে কেউ থাকবেন না। তো যারা আমরা রয়েছি, যারা আসবে আরো, তাদের বোধহয় এই কথাটাই মনে রাখার জন্যই বলছি সংঘ ঘোষের কথায়, কিছুই কোথাও যদি নেই তবু তো কজন আছি বাকি, আয় আরো হাতে হাত রেখে, আয় আরো বেঁধে বেঁধে থাকি। থ্যাংক ইউ।
একটা সমাপ্তি গানের জন্য স্টুডেন্টদের তরফ থেকে আমি স্টুডেন্টদেরকে স্টেজে দেখে নেবো।
ঠিক ঠিক।
না, ওটা actually মানে ইউটিউব যেটা
বলে দিই এটা ফোল্ডারটা যেটা আছে, আচ্ছা এই যে হোয়াইট ডাউন যেটা চালিয়ে দিয়ে ওটা অন করে দাও, ওই ক্যামেরা যেটা চলছে ঠিক আছে, চালিয়ে দিয়ে তখন
এত সুন্দর একটা পরিবেশনার জন্য শিল্পীদের অসংখ্য ধন্যবাদ। আচ্ছা, as we come to the end of this memorable celebration, I would like to express our sincere gratitude to everyone who contributed to making this event successful. We are deeply